This
This,
conference will now be recorded.
there she is. I just can't start my morning without hearing that. I'm all confident now and we'll move forward. You should be seeing the first slide, um, and maybe you're not because I should be sharing to show you my first slide. Give me a second to get that rigged up. So I'm going to make me the presenter. Yes, I want to be the presenter. And now I want to make sure that I'm sharing um, a screen. That screen. And now I'm sharing my screen that's got my Outlook going on it, which I'm going to close, and it's got the slideshow for today. Dave, have I got egg on my face, or is there a slideshow up and running now?
Uh, I see a slideshow, yeah.
Good. Then that's it. That's better than egg on my face. Um, so let me, like usual, I'm going to click through the first couple of slides. Dave, I invited Brian to drive for a little while this morning, if
Okay,
that's okay with you.
fine with me.
But if you keep up and Brian and I
Hmm.
get tired, we're going to switch and get you to take over for us. So we got a backup, Brian. Um, and I will remind everyone of a discussion I had with one of our students is that the classes are organized such that I mean for you to be able to keep up with the things as we're doing them. But if in any class you get behind, the files I send out in this morning have a start here, which will be picking up from right where we left off in the last class. So no worries if you get a little bit behind on one day, you have the next couple of days to try and get caught up. But if you don't, when you show up for class, we'll start out with the perfect starting place for that class. Again, the first couple of slides, everybody's been great. I can't think of a class I've enjoyed more in terms of interactive response and everything. So keep that up. And if you need to, you can call in. And we got here, Brian. Does this look familiar to you?
Yeah, some of the stuff though is not on that sheet, but
You're right. We got almost here, and we left like 6 or 7 slides last Tuesday that we said, okay, we're going to come back on that. And I said I would take those slides, like this detail and this legend. There we didn't get to them, but I'm going to. I took those slides and I add them into today's slideshow, but I added them at the end because getting our work documented, getting it on a sheet to print out, that's an anytime project. In in most cases, it's in at the end of the project. You get it drawn, you get it calculated, you get it coordinated, you get it stock listed, and maybe before the stock listing, you want to get it printed out and sent for submittal. And then you get it stock listed, and then you need to get it printed out for the field. And this this is meant to be that documentation on a piece of paper to go to the submittal or to the installation. However, you can do it anytime. You can do it as you go, or you could do it at the end, or you could do it in the middle. So we've done half of it early in the process, and we'll get to the rest of it before we have to actually print it out, hopefully later today. So time out on that, on the documenting what we did already, and we're going to spend today on hydraulic calculations. Hopefully we're going to get through that, and we'll have time for those last few slides from Tuesday. Again, I've broken the slides up into pretty colors. The blue slides are just almost a warm-up exercise, but they're the basics, the sort of bare bones. What do you have to do a calculation? And I put a spoiler alert in there on the blue bar at the top there. It says, what do you need to do a hydraulic calculation? You need operating heads, connected model, water supply point. Operating heads, connected model, water supply gets you a calc. So we're going to do that several times. We're going to do it in the blue, we're going to do it in the yellow, we're going to do it in the green, we're going to do it in the red, over and over. The calcs may vary in what we're calculating or how detailed we're getting, but it's always those are the three basic things we need to do. And then when we've got the blue slides, we're doing the show off of what's that basic um, base level stuff we need to do. Then we're going to get when we get the first calculation done, we're going to spruce it up some. First time through, we're going to let the computer make up reference points. Second time through, we say, no, I want to number the points this way. That's an example of some of the sprucing up that we're going to do and run a calc again. And then I'm going to take over and drive for a little bit and just take you through what if there's a fire pump? How do we run a calc when there's a fire pump? And what if I have a standpipe? How do I run a calc when we're running the standpipe? So I'll go a little bit faster on the green and the red slides. And if we can get through those, we'll come back and add details to our sheet. We'll add a sprinkler legend or a sprinkler schedule to our sheet. And we'll add some general notes to our sheet. So I'm going to click to the next slide and show you where we're going. Brian, I guess I'm going to ask a second thing of you. You found that project that I sent out to start with this morning. You should also in the same file, in the same folder, you should find a PowerPoint PDF.
Yeah, well, let me look here.
And the file that Brian found, I will double check this, but should have been in C, HES, Hydrotech for Revit Online Basic, and then it's called blah, 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 start of day for lesson 3.
Let's see.
And as soon as we get it open, we're going to do a save as.
Lesson 3, calculating PDF. Is that?
That's it. That's it. If you just double click it, it'll probably open in Edge or Google Chrome or something. It'll open so you could be looking at a PDF.
It opened in Bluebeam review.
Nice. Okay. Well, Bluebeam is nice.
Okay.
Then I'm on slide 7, and I think if you click in Bluebeam to page 7, you'll see the same thing in that PDF as I'm showing on the screen.
Yep.
Cool. So I'm going to make you the presenter, and we'll switch drivers here. Make presenter. And then the screen that you have Revit on, that's the one we're going to want to share. You did that before. And I'm going to take this guy and put him up there. And I'm going to make this guy big. All right. So sneak back to Revit, and we're going to do what this thing says. And I'm going to drag everybody through that. Yeah, I like what you're doing there. And if you click there, let's even close this project and reopen it, Brian. So just pick the X on fire protection floor plan. Yep. And save or don't save, I don't think it matters. We haven't made any changes. And did that close Revit?
Yeah.
We didn't really mean to do that, but go ahead and open Revit again.
Yeah.
I know you picked the X on Revit, and
Yeah.
and that worked. But I'll remind you, that there's tabs in the drafting area at the top of the drafting area, and there was an X on the tabs that we had open. And if you do that, it closes the project without closing Revit. But now in here, I want everybody to see us pick open dot 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 button. And then drive to C, HES, basic training. That's it. And in here, we should find that start of day 2. Not that one. The one that's at the top of the list, Brian. That
Start
one.
of day 3.
Yes, start of day 3. And I sent it out. I'm going to say mistakenly. I intended to send it out as version 23. I think that's bad on my part. I tweaked it and saved it on my disk, and I didn't put it in the zip file. We're still good, but that's, I'm explaining to myself why we're doing this upgrade. Anyone using 24, 25, or 26 would be doing an upgrade anyway, so it's not bad that we're doing the upgrade. And as soon as this is open, Brian, we're going to remember to do a file save as and put our name in the file name and resave it. That will do 2 things. It'll identify it as us, but the other thing is that it will keep us from having to run that upgrade again if we open that newly saved file.
Okay. So I just overwrite the file I created already.
Yes, so do file save as. A project, that's it. And then save it so that it has your name in it. That's perfect. And save. And overwrite is fine. Okay, so that looks slightly different from what I had on the slide. I do this over and over and over, and I don't think I could ever do it exactly the same way twice. But it's got a bunch of stuff documented and not everything. And we're going to come back and document some more stuff at the end of class. And then in the project browser, you're right on top of it there, Brian. We found the fire protection floor plan, and that's a place for us to work. If you could put that slide back up on the screen, slide 7. And then move on down to slide 8.
That's
First
not
thing
going.
the first thing we're going to do and talks about in slide 8 is run the setup button. So we're going to go to the HydroCalc ribbon and pick the setup button. And that's going to just make sure that the project, whatever state it's at, is prepared for or ready to do hydraulic calculations. Specifically, we're going to make sure we have properties on all of the sprinklers and the fittings and the pipes and the valves. And those properties came either from Hydrotech or from whoever built the family that we're using, and it adds those properties. It's best run after you're mostly done with the modeling so that you have sprinklers and pipes and fittings and valves in your project. And once your project has those parameters, anything new that comes into your project will assume those parameters. So you don't have to run setup over and over and over every time you run stock list. Once per project. So I think we're done with slide 8 and we can move on to slide 9, which says we're going to identify the operating heads. I'm maybe I didn't do a good overview here. We're going to calculate 0.15 over 1500 with a water supply of 55 static, 44 residual, and 1150 flowing. And we're starting by identifying the operating heads. There's two ways to do that. You can actually draw a box around it and then use the box to identify the heads. But in this basic first time around, I'm saying I'm just picking the heads and telling those heads that they're operating. So on that FP floor plan that you opened, we're going to click and drag a window around 3 branch lines, 5 heads each on those branch lines. And I like where you're starting, and I like where you're going, and that's going to be perfect where you're at there. Now, obviously, Brian, when you pick that, you got pipes and fittings and sprinklers. But if you look in the properties box right now, the beginning of the properties box says common 64. Do you see at the top of the box there?
Yes.
Yes, that's you picked 64 items. If you do that pull down, it says I'm trying to show you the properties that are common to all 64, but there's sprinklers 15. Click on that. And now the properties box dials in specifically to the properties for those 15 heads. Even though you picked pipes and fittings and stuff, there's the properties of the 15 heads you picked. You like it?
Yep.
And scroll down to fire protection. And I'm going to kind of skip one slide ahead just a little bit here, and we'll review it in slide 10. But in slide 10, we say the fire protection has 5 properties in it that we really, really care about. The first one is density, and that's already 0.15. It's over a week ago, but when we did the spacing and layout, we put 0.15 in when we laid out those heads. And minimum pressure, we put 7. We did that also. And the 100 square feet area, we did that also. So those 3 we kind of got for free. The next one says flowing. And you see it's kind of a gray check mark next to flowing. Gray means some of them are and some of them aren't. Or maybe that's checked or maybe it's not. If you click that check mark, that's selected, Brian. If you click it again, that's unselected. That's not flowing. And you click it again, and now it's flowing. There's no getting back to the gray. We've said these 15 sprinklers, all of them are either flowing or they're not. And then under remote area, we're going to put in RA1. We could put anything unique in there. We could spell out remote area. We could just put 1, but remote area 1 is perfect. And I'm going to be chicken, Brian, and I told you can put anything in there, but let's get rid of the number sign. I'm going to put letters and numbers, and I bet even money the number sign would be fine, but I'm not a gambling man this morning.
Okay.
So those are the 5 properties that identify the head as operating. Those 15 have that check mark and the remote area RA1. All the others don't. So when we calculate, it knows it's calculating those 15. All right. So let's go to slide 10. Yep. And that's where it says you got to fill in those 5 parameters. And we did that. So it is okay if you want to go on to slide 11. And I said in HydroCAD for AutoCAD, you're used to drawing a polyline, I think, Brian.
Yep.
And then you've got a button that says pick on that polyline, and I'll put little stars on all of the heads to say that they're operating. There is in Revit, it's not a polyline, it's a filled region. And we could draw the filled region first and then use that to identify which heads are operating. But I want to show you two different ways. And for now, I'm just going to say we can do that. We're not going to do it. We'll do it later. The net result, if we do the filled region, will be to fill in those 5 properties that we just did for those heads. Does that make sense?
Yes.
And another thing that's different between AutoCAD and Revit is the sprinklers have properties to say whether they're operating or not and what area they are and all of that. In AutoCAD, the sprinklers are just a block. To get them to be operating, we put another block on top of that block and hope that they stay together so that we know that block is identifying that block. Really cool thing, I think, in Revit is the sprinkler is an object that can support as many properties as we need. And we don't have to finagle getting those things to stay lined up. Okay, let's go on to slide 12. And that's the middle of the song, connected model. And all that means is we're going to have a supply point. That's where the water comes in. We've just identified the operating heads. That's where the water comes out. There obviously has to be a path for the water to get from the supply out to those heads. And this slide shows us using the walker, and the walker lets you pick a pipe, and every other pipe that's connected to it will get selected. Easier, I'm telling you, it's easier than picking a window around stuff, because the window sometimes can miss things. The window can't possibly go off of this view, but the walker will. It says that one's connected, I'm selecting it. That one's connected, I'm selecting it. So even if we were zoomed in and we were like real close to the remote area and we picked one pipe, it would find all those other pipes connected to it. I think we can treat ourselves to slide 13. This was just saying the walker's a good idea, and 13 says you actually type WW or you pick walker off of the HydroCAD, HydroCalc, or HydroList ribbon, and then you pick a pipe and you'll see everything light up. Let's just go do that, prove it to ourselves. So what's your preference, to find it on the ribbon or to type it as a shortcut, Brian?
Yeah, if I know the shortcut, just type the shortcut.
Okay, and I'm going to tell you, it's on slide 13, and I'll tell you it's WW, walker, and then pick the pipe. And if you pick any pipe, and when you pick that pipe, it says, oh, that's connected to the riser nipple on the left side of me. Oh, that's connected to the branch line. Oh, that's connected to the next branch line. It wanders everywhere that it can. You will notice, at least in this plan, that I'm not convinced that the underground got selected. Hit escape, 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 and do the walker starting on a piece of the underground. Yeah, you see it selected the underground, but it didn't select the system. Zoom in real close to where it switches. You see it got the underground pipe and it got the elbow at the bottom of the underground, but it didn't get any of the sprinkler system. Escape, 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 and very carefully pick on that elbow. Not that one. Escape, escape, escape. There's one that's it, the one at the bottom. And the properties for that elbow in the very top set includes a property that says system divider. And it's a blue check mark. Uncheck that and do the walker again. Okay. Do you see what happened? There was a property on that elbow that said, don't go through here. It's a system divider. So the walker sees that and says, "Oh, I'm going to stop here. He told me to stop here." So I can take my system and divide it up into various pieces if I want to. Um,
Is that
and
for any fitting we can put that on, the divider?
I'm sorry, say again.
Can we put that divider on any fitting?
Any fitting or any pipe,
Got it.
and even on a valve. So pipe, fitting, or valve. Um, and in the bigger picture, I'm going to say if I had a 4-story building, when I run the calcs, and it's not bird caged, when I run the calcs on the third floor, I want all the piping on the third floor. And I might even want to stop there and just do a calculation to the floor control assembly. Or I want to do all that piping plus the standpipe, the interfloor connections. But I don't need to submit for calculation the second floor, the first floor, or the fourth floor. And things obviously go better and faster if I'm sending what needs to be calculated, not the whole world. So typical in a high-rise building, I'll model the entire building, but I'll put a system divider on the butterfly valve at the floor control for each floor, and then 2 picks of the walker, and we can get that to go. So let's put a system divider back, Brian. Escape, escape, escape. And this time pick that elbow at the top of the entrance, that one, and put the constraints property that says system divider and check mark that. That's it. That's the one.
Okay.
So we're saying that's a system divider. And if you do the walker again on the system, it'll stop at that elbow. It'll include the elbow and it'll stop at the elbow. And do not hit escape. Don't start over. Just pick the walker button again, Brian. And pick on the underground. So you see, you can get multiple selections by using the walker over and over. And if you had a huge warehouse, a 1,000,000 square foot warehouse with 30 sprinkler systems in it, if you're calculating system number 9, you only want to do the walker. It would be good to have a system divider on each control valve, and then you could click on system 9, and you could click on the underground loop, and you'd have all the piping that you needed for that. Brian, had you used system boundaries in HydroCAD before?
I haven't. Now I've used the stop function. Yeah.
Yes. That relates more to the stock listing, but it's
Yeah.
this idea. I want you to do all this stuff, but stop here, and this is that idea. If you'd used the system boundaries, it's a much bigger pain in the neck than this because you've got to draw a boundary around the stuff you'd like to isolate, and that's not always. It's not always.
Yeah.
Not always a rectangle. It could be a rectangle with a long tail on it for the underground or something.
Yeah. Sorry, I misunderstood. Yeah, I would. Yeah, I've used the system
you have
boundary.
used. Okay.
And then the
As
floor.
as soon as I said it was a pain in the neck, then you remembered.
Yeah, because you don't always get the rectangular. You got to draw
you got to
it
get
out.
fancy with it. So this is way easier because the program is recognizing that's connected to that, it's connected to that, and the shape doesn't matter. It's just what's connected. Okay, I think I've beat slide 13 to death. Let's move on to slide 14. And the good news here is that we talked about this, and I can use this as a summary. We did it in the plan view, but we picked on that elbow and we made it a system divider. And I think that lets us go right on to slide 15. That says, then you can select, you've divided it into pieces, but you can still get everything by picking once on one piece and then picking once on another piece. The only regretful thing in this example, Brian, is why are we doing this? For a 60 by 80 foot warehouse, um, the answer is so I can show you something, but it's not particularly useful. But if it was a large warehouse or a high rise building, can you appreciate the value of that?
Absolutely.
Cool. Um, Okie doke. So let's move on to slide 16. Brian, you're doing a great job of driving today. I'm not gonna try and lay blame at all on Dave for it took a long while to get through slides yesterday or the day before. But we're cruising here. Let's cross our fingers and hope it keeps going here. Um, so
You just
in
jinxed it, Elon.
I just jinxed it. I know, don't it? I'm sorry. um, So we're off to our third part. We need operating heads, connected model, water supply. And the water supply is actually two things. It's a place and it's an amount. And the place is the supply point and the definition is the amount. And I'm going to go with this slide. There's really no reason we couldn't calculate out to the street, but I'm going to have us follow what's in the slide here. We're only going to calculate as far as that first elbow in the underground. Um, so if we go back to the plan view and zoom in on that first elbow in the underground, perfect, and then go to the hydrocalc ribbon, and over on the left in the setup panel is supply point. Three more buttons to the right there.
Well,
No harm in running the setup any number of times. You only need it once per project, but no harm in multiple times. And now pick that elbow. And I think on slide 16, I describe a little bit more about that. The supply point can be slide 17. I'm sorry, I lied. The supply point can be on any fitting. An elbow is a fitting, a T is a fitting, a butterfly valve is a fitting. That was a question, Brian. A quiz.
elbow.
Elbow is a
And
fitting.
fly.
Is it?
It's a valve, but yeah,
So
elbow.
you and I might loosely think of it as a fitting, but I'm going to take this opportunity to say Revit has four basic components of a sprinkler system, and each of them behaves in its own way. A sprinkler doesn't behave like a pipe, does it?
No.
I mean, it doesn't look like a pipe. You can't make it longer or shorter. You can't change its diameter. It's pretty much a fixed device. So sprinkler is one of the components of a sprinkler system. Pipe is another component. A fitting connects one or more pipes. So a cap, an elbow, a T, a cross, those are all fittings. And when you draw one pipe into another pipe, it automatically creates a fitting to connect them. But the valves behave differently. They want you to have the pipe already drawn, and then you stick it on the pipe, and it takes a bite out of the pipe and puts itself in there. So those, in Revit terms, are called pipe accessories. So the main ingredients are sprinkler, pipe, fitting, sprinkler accessory. And if I used sprinkler terms, it'd probably be the same thing, except I'd call the last one valves. And this statement says you can put this on any fitting. So the butterfly valve is right out. Can't do that. Fair enough?
Yep.
And there will never be more than one supply point in a project at any given time. And the good news is that means if we said, ooh, we changed our mind, we don't want it at the elbow, I want it way out at the street instead. The only thing you have to do is put the supply point in this at the street. It'll automatically erase the one at the elbow. That's a good
Okay.
thing.
Yeah.
And we just found out what a system divider is. The water supply point will serve as a system divider. So when we do the walker, it'll walk up to and including the supply point, but it won't go through that. I might even want to take a second and prove that to ourselves. Sneak back to AutoCAD, to Revit. David's the one that wants to sneak back to AutoCAD.
Mhm.
And now WW for the walker and pick on the sprinkler system. And then WW to get the walker going again and pick on the underground. And remember, the whole underground lit up before, but now only to the supply point.
Yeah.
The supply point is acting as a system divider. Is that right? And
Nice.
while we're here, this is written on slide 17, but you don't have to go back there. It says it can be inserted to allow for divide and conquer. I want to credit Julius Caesar for divide and conquer. He would go conquer a country in the middle of two other countries, and then he could pick on the other guys one at a time, rather than trying to do battle with the whole of Europe at one time. When we try to run a calc and we get a problem and we can't get the calc to run, we can play like Julius Caesar and divide and conquer. Zoom out just a little bit, and presuming we have this selected, David, Brian, and we want to run a calc, and for whatever reason, the calc won't work. We say, wah, what's wrong? If we move the supply point, so the calc didn't work trying to calculate all of this stuff. I'm going to have you actually move it to the elbow between, click on supply point, and then pick on the elbow between the cross main and the feed main. Yeah, that's the
This
one.
one?
Yep. So start, do it again. Do supply point. No, use the command for supply. Hydrocalc supply point. And do you see it erased the other one?
Yeah.
But you can't move it. If you move it, it's still associated with the place the fitting that you picked originally.
Okay.
So you were going to move it. That wasn't going to do anything. But we ran a calc before and it wouldn't run. If I run a calc now and it does run, that tells me something, doesn't it? The calc will run up to this point, but it won't run through this point out to the underground. What does that tell me?
Something's wrong with the riser.
There was a problem somewhere between this elbow and the original elbow. That's good. That's good information. If I move the supply point here and I run the calc and it doesn't run, what does that tell me?
There's a problem before the supply point.
Exactly. It's somewhere to the left of that supply point. Given that, I could maybe put a coupling in the middle of the cross main and put the supply point on that coupling. And if that calc runs, then the problem is in the right half of the cross main. If it doesn't run, it's somewhere in the branch lines or in the left half of the cross main. And by moving the supply point about 3 times, you can narrow the problem down to like 5 pipes or something. And worst case, you could just bloody redraw those 5 pipes to make sure you had a connected model.
So you're saying like if you run the calc from here and it says cannot I thought you meant like there was no safety or something like that. But if
I'm
it's
sorry. Yeah, no, it just plain won't work. I'm
okay,
not work or not work. It just plain won't give you an answer. It says I can't do that,
okay, I got
right?
you.
And the I can't do that could be, it looks like a connected model, but there's this tiny little spot that's missing a pipe or something. Looks like it's connected, but it's not. Um, we don't know what the problem is, but by moving the supply point around, we can find out where the problem is. And thanks for the clarification. I'm, I I meant to say the calc refused to give you an answer. It refused to actually run the process. Okay, so let's put the supply point back at that original elbow. You just pick supply point. And there it is. There it is.
Okay. I
Um,
don't know if I got it on the elbow. There we go.
I don't blame you for wondering. I was sort of wondering that too. I think there's actually, it's okay to move it after if you want. Go ahead and move that out off to the side a little bit. Just grab it and move it. That elbow was drawn funny. It's like 4-inch pipe to 6-inch pipe, and it drew a 4-inch elbow and then it put a reducer. Can you see that?
Yeah.
So that reducer is a fitting. And when you put the supply point in that area, it went on the reducer instead of the elbow. I don't think it would change the calc, but you and I noticed it, and we're convinced now it's on the elbow. That's a good thing.
Yeah.
Okay, let's treat ourselves to, yeah, the slides are slowing down since I said we're cruising. Let's treat ourselves to slide 18. And we've done the where is it, and now we need to do the how much is it, and that's a button that says define supply or just the shortcut DF. And I show picking it off to the side of the riser in the plan view, and it's going to be 55, 44, 11, 50. So back in Revit, we're going to click define supply, and we're going to pick off to the right of the riser there somewhere. And now, and it's movable anywhere you want. And we want to define 55, 44, 11, 50. Two ways to do it, David. If you, Brian, two ways to do it. Click on the box itself anywhere and select the whole box. And do you see the properties off to the left in the properties box? You can change
Yeah.
numbers in there. Alternatively, if you pick again, you could highlight the 90 right in the drawing and you can change it there. Either one. And watch when you change it, you're changing it in both places at the same time.
55 and what was
Yep, 55, then 44, then 1150. Perfect. And we'll leave the 250 for hose.
Is
And
this a tag or what is this?
it's a generic annotation.
Okay.
That must
So
be a
what?
Dave question.
Yeah.
Does that have a follow-up question, Dave?
Nah, I understand now. I was just wondering if it was tagging something, but no, you said it's just a generic annotation.
Generic tag, yeah. So
Yep.
it needs to be in the model, but it doesn't
Yeah.
actually associate with an object.
Yeah. Just wondering if it was associated. That's all. So, but it's not.
Yep. Okay, and now we're going to move to slide 19. And we're getting ready to do the dirty deed here. We want to run a calc and say, can we get 0.15 out of each one of those sprinklers if the pressure coming into the system at that elbow is 5544? We've got inch and a half. By my recollection, we have inch and a half mains and inch and a half lines and 4-inch mains. Brian, would you take a guess whether we have enough pressure to make that work or not?
I think we would.
Yep. Does anybody want to? Anyone else want to guess? vote against or root against Brian? All right. Well, let's prove it. We could just quit here, and when the underwriter or the authority having jurisdiction says, "Where's the calcs?" We could just say Brian said it was going to work.
That hasn't worked all these years, so I don't think we should try it.
So we probably better get a calc, even if we know that it's going to work. And to do that, we're going to, I'll read this and then we'll go do it. We're going to walker the system, and then we're going to walker again on that little piece of underground. So we have a connected model. And then we're going to go to the hydracalc ribbon, hydraulic calculations button, or type DC for do calcs. And that'll bring up a dialog box. I think that'll bring up a dialog box in slide 20. Let's click on slide 20 because we can memorize that much. It's going to bring up this dialog box that we're going to need to fill out, and I'll leave this slide up and I'll talk about filling this out when we get there. So back on Revit, you could type WW and pick on the system, and then you could pick WW and pick on the underground. And then you could type DC, or you could go to the hydracalc ribbon. And in the calc panel, the one that says hydraulic calculations, not the one that says launch hydracalc. That launches the standalone calc program. So we're going to pick that button that says hydraulic calculations. And we're going to give me a second. That's just saying there's a newer version. That's not you're dead in the water. It's just
Okay.
There's a newer version. So we're going to say okay. And there's that dialog box. Now I guess I'm going to divide this up into two major things that we're trying to ask for in this dialog box, Brian. The stuff at the top is what do you want to calculate, and where do you want to put that calculation? So this is going to read the model. It's going to create a WXF file, an input file for the standalone calc program. And
Okay.
the name of it is going to be Brian 60 by 80 2023. And off to the right, you see where it says area and it's got RA1?
Mhm.
We only marked 15 heads. But if we had marked 15 as RA1 and a different 15 as RA2 and a different 15 as RA3, we'd have a choice. Which one of those three do we want to calculate? That makes sense?
Yes.
There's two relatively new buttons right below that. One with a check mark that says Calc Summary of all areas, and the other one that says Calc Summary of selected areas. If you check, we're going to leave both of those unchecked, but if you check either one, it's not going to bring up the standard HydraCalc input program. It's simply going to skip that and say, I calculated it, and this is the pressure and flow. Pretty cool if we had 3 different calc areas and we didn't know which one was really more remote than the other.
Mm-hmm.
We could get the answer before we did the work on any of them. We could mark these 15 heads, those 15 heads, and those 15 heads. And then we could say, run all 3 calcs and just tell me how the pressure and flow looks for those 3 areas. And we could say, oh, I'm surprised. The lower level was the most remote, but now I know. We're going to leave those unchecked. And as a result, it's going to calc RA1 and it's going to bring us to the standalone calc program. By default, it's going to save the input for that thing in C, AGS, basic training, your file name. That by default, it's the same place as your Revit project is saved, but there's a browse button next to it. You could put it someplace else. The elevation adjustment, I'm saying you could ignore and it'll never give you a wrong answer. But if the architect said that the finished floor was 187 feet and we made level one be at 187 feet, and it was just a single story building, we'd have sprinklers at 205 and the riser valve was at 183 and the underground was at 181 or something. And the reviewing authority said, "What? This building's only 20 feet tall. How come the sprinklers are at 205 feet?" It's because we're reporting the absolute Z coordinate of the sprinklers. If I wanted to make that particular question go away, I could put minus 184 feet in here, and it would take off 184. Then the floor would be zero. Does that make sense?
Yeah.
It's one of those, I tell you now, you believe me later. So the good news is, if you don't understand it, just don't worry about it. You can ignore it. And if the authority AHJ came back and said, "I don't like your sprinklers at 205 feet," you say, "Give me a minute." You could come back in here and type minus the floor elevation, and run the calc again. He's going to get the exact same answer, except the sprinkler will say it's at 20 feet, not 205 feet. Okay. We didn't put any reference points on the drawing. So the computer is going to make them up. And that last piece of information in the top half says, go ahead and make them up starting at 1. So it's going to number the reference points 1, 2, 3, 4, 5, 6, 7, 8, 9. First time around, that's my recommendation. Do that. If you're doing a 16 system warehouse, the reference points in system 1 could reuse some of the same numbers that you have in system 2 and system 3. It's system 2 had 1, 2, 3, 4, 5. System 5 had 1, 2, 3, 4, 5. There's a check mark to allow you to do that. By default, we say, nope, every reference point has got to be unique. So that's an option to you. Okay.
So can you go through and like remote area one, all the sprinklers be called S101, and then the mains A101, and then at system two go S201, and then the mains like A201 back to the right. You know what I mean? Separate.
I do. We're going to do exactly that. There's obviously not enough information in that tiny little box to tell it to do that. But what we're going to do instead, and we're going to do this in class, is we're just going to run the calc once and let him make up reference points. And
Okay.
then we're going to use a tool called renumber reference points. And we're going to say, we want S101, 102, 103, 104, then A, 101, 102, 103, 104. Really easy to do, but this is Revit. It's the reverse of it. We're going to let him put the reference points on, and we're going to change them.
Okay.
Instead of, we'll go ahead and put all those reference points on and get him to use those. The advantage to this reverse thing is we only have to number the reference points that really, really are reference points. If we number them ahead of time, we might forget one, or we might put in an extra one. We're kind of guessing what the calc needs, right?
Yeah.
So they both work, but this was the way that worked best in Revit. Okay, other questions about the top half of this dialog box? So Brian, Brian, this shows that we used 4 different kinds of pipe, maybe even more than 4 kinds of pipe. And try clicking that two-way arrow there. See if there's a page 2. Yep. So 5 different kinds of pipe. You with me?
Uh-huh.
And go back to that first page. Just looking at the very first entry, it says arms to welded lines. Would you say those are lines, mains, or underground?
Lines.
I think I had a big hand in reorganizing this dialog box, and I claim I made that a bunch of wicked easy questions. The I'll go three more. The next one
Okay.
down says lines welded. Is that lines, mains, or underground?
I would say those are the welded branch lines on the first three bays over there.
So we're going to call them lines. And the next one, lines threaded, we're going to call those lines. And mains welded, I think I'm going to call those mains. And that other one, we're going to call that underground. Easy answers, right?
Yes.
Um, but the first time you use this, there's an old fashioned way we have to get the other two columns filled in. And once you do it once, the computer remembers. You won't have to do it again for those pipe types, unless and until you use a sixth type of pipe. You'll have to go back to the old-fashioned way. And I've got a project in the works to say we're going to automatically guess everything is Schedule 40 C120 for the right-hand columns there.
Mm-hmm.
Turns out that they're not C140. You could That's C120. You can just type C140, or if it's not um, Schedule 40, you could make it Schedule 10. For starters, right now we've got to do that in the classic mapping. So over there on the left, click Classic Mapping. And I really objected to this one because the five pipe types aren't obvious. They're in that pull down list. You see where it says lines welded? Pick on the very first one in that pull down list. And I'm not going to explain how or why or anything because we just want to get the heck through this. For each one of the ones in the list, we need to pick load defaults just to the right of that and apply. Find load defaults again. Yeah, right there. Now, go back to the pull down list and go get the next one. Load defaults, apply. Go to the pull down list, get the next one, load defaults, apply. Pull down list, get the next one, load defaults, apply. Last one, load defaults, apply. And if all we had was this classic dialogue, gag me with a spoon, then you'd have to be paying attention to what the defaults were and all of that other stuff down below. But lucky for us, we can leave that behind. If stuff's not filled in, load defaults apply. Then switch back to the new mapping and click on lines for the first one. Good. Lines for the next one. Good. And underground. Now, the underground came up cement lined, but which I think is fine. Go back to the other list. The the arm overs I think would be Schedule 40. The welded lines I think could be Schedule 10. So double click on that where it says Schedule 40. And you can probably double click on Schedule 10 or click Schedule 10 and OK. And then the lines threaded would be Schedule 40. The mains are Schedule 10. I think we're all good to go.
Yeah, Alan,
Go ahead.
this is John. Could you go through that one more time with the classic?
Yeah, we'll do it.
I'm sorry, it just mine was not looking the same as Brian's was.
Let me make you it probably has to do with the version of Hydrotech for Revit. Let me make you the presenter so we can see what yours looks like.
Okay.
Up. Wait a minute. You almost became the organizer, and then you would have to teach class the rest of the afternoon.
All right, we're taking a break.
Okay.
Already more than
I like
last
them.
year.
Yeah, I like them already.
So you'll have
Okay.
to look in the center.
Where You're the big screen guy,
Yeah, I'm the big screen guy.
and
Sorry.
I can do that. I'm zooming into the center.
Okay.
Okay, so switch to classic and pull that, open that up and make sure you're starting on the top one. Perfect. Then click load defaults and apply.
So the apply is down there by fire sprinkler underground. Is that correct?
That is correct.
Okay.
But
That didn't make.
when you pick apply, it just makes sure that the stuff that's showing up in here, and we're not even caring what's showing up in here, but that there is stuff and that's recorded.
Okay. Do
And
I
now
can
go to the next one down on the list,
right here
load defaults. That's it. Load defaults, apply.
apply? Okay. I
Next
didn't
one.
understand that, so now I do. The
It
apply
felt
button.
like you were applying underground or something.
Right. That's not what I
Yep.
was doing. I'm that
You're
the button.
applying that whole grid of information.
I got you.
Alan, is this something we have to do per project or just a one-time setup?
Once per type of pipe you ever use.
Got it.
Okay. Now quickly put Brian back in charge.
Okay, teacher.
I don't know if we need to do that.
Okay, Brian. You're invited.
Thanks.
Okay, so um, if we had flex sprinklers in our calculated area, we would use that last line where it says fire flex pipes. And I'm saying we'd make it say schedule 40, we'd leave it on schedule on 120, but we would type in the equivalent length we were going to use for those flex heads. We don't have any, so it doesn't matter whether we fill that in or not. Does everybody have this newer matrix filled out, and does everybody have a continue button that's lit up?
Yes.
Would we want to change the welded lines to schedule,
10.
or we just change it on this screen? We don't have to change it on the
Once it's in here, you can change it, but if it's not in here yet, you have to go back to that classic to get one in there. Everyone good? So I think we're good to pick continue. And it might have come up on another screen. There it is. So it did a little fuel gauge dance or a jig, and then it came
Yeah.
up on the screen. And there's a message box that most of you will see that looks like an error. Yeah, this is the
So
fuel gauge. We're just going to leave it alone. It takes care of itself. Um, but there was also a box that said a big long message that said, "Oh, we've taken all the stuff out of your Revit model and we've put it in HydroCalc and it's version this and it's version that. Pick OK." And there's a button in that same dialog box that says, "Don't show me this again." Um, I I am tempted to pick "Don't show me this again," but then I wouldn't be able to show it to you. Um, Dave, by that description, do you know what I'm talking about?
I think I'm actually getting an error.
That's not
Just,
an error.
yeah, it's not that.
Okay.
Did you get this process timeout like mine did?
I got an error 1308 source file not found. See Autodesk
Ah,
AutoCAD.
oh, okay.
I
So,
got Big Jerry's making a big mistake.
so who should I make the presenter?
Did you want to see my error, Dave? Dave is speaking right now.
Yeah. Uh,
So do I just hit continue?
just hang on.
Anyway?
You can pick
Okay.
continue. That's fine. But let's see what Dave got. There we go. Okay. So this, when I was talking about the calculation didn't work, this is an example of the calculation didn't work.
Okay.
Are you with me?
Yep, I'm following now.
Um, error something, and this is a really weird one because it says AutoCAD 2021. What? I didn't know that we were AutoCADing anything. And
Yeah.
it's talking about C, Autodesk, AutoCAD 21, X64, AutoCAD, PF, Root, Sample, Visual Lisp, blah, 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 PRV, verify that the file exists and that you can access it. Let's, I'm tempted to just pick ignore.
Yeah. I'll say before that error popped up, there was one right before it. I can't move it onto the screen. It says, please wait while Windows configures AutoCAD 2021.
Yeah. Okay. That is in, I'm suspicious that there's even a HydroCAD card for that. That's a installer problem in AutoCAD.
Okay.
Um, and I want to try and take advantage of the teaching opportunity here. Can you take a screenshot of this so that we can
Yeah,
minimize?
I'll take a screenshot and send it over to the chat.
Uh,
Is that what you like?
um, fair enough. You can probably hang on to it.
Or
I
no, that's right. I can probably just throw it on my screen real quick.
Yeah. So let's cancel and find our way back to Revit.
This is Revit.
Okay, and I zoomed in a little bit. This is my fault. I zoomed in a little too much. Um, so we're going to cancel here also, Dave. Can you pick cancel on this
Yeah,
dialog?
yeah, it's on another window. Calculation. There. So after canceling everything, that popped up.
Son of a gun. So it let us through anyway.
Okay.
And did someone else have an error that they were trying to describe?
Hi, I'll mention I'm getting an error saying it's gone like 200 passes without balancing.
Okay, good. I want
I
to
got the same one.
make one of you the presenter and go chase that one down. And what I'm really trying to chase down is not how to fix your immediate problem, which we want to do, but I want to explain divide and conquer, and I want to and I want to explain when there's an error, what do I do? Um, uh, so Dave, hang on there. Brian,
Yep.
hang on there. I think this, what do I do when there's an error, Dave? You can later go to HydroCards and look up error 1308. And I'm pretty sure we're going to find instructions that say you've got to get the installer to quit or something. And there's details on how to do that. But why bother doing that now if right now it
Yeah.
looks like I'm saying it looks like we're past that and it's working.
Mm-hmm.
Who should I make the presenter for 200 passes?
Yeah, I'll mention that I think I discovered it. I still have the divider block on my elbow after the supply point, and once I turned that divider block off, Calc ran fine. Can demonstrate
Okay,
that if
so
you
you
want.
cheated and said, I think I can guess about that.
I took a guess.
Yeah, that's good. And there's nothing wrong with that. I think always, if you get an error, try it again. And sometimes when you're trying it again, something else occurs to you. Who else had that 200 passes error? Nobody. Well, I'm losing my chance.
Well, mine just said process has been running for an unexpected amount of time.
And that one, I'm saying you can just say okay.
Yeah, but it keeps popping back up after it runs.
And And do you not have this input screen, this spreadsheet thing hanging around
Yeah,
someplace?
yeah, it's open.
So just pay attention to it. Don't worry about that running unexpected time. Don't worry about it.
Okay.
And pay attention to the screen. Okay, we're going to delay talking about divide and conquer again, and we're going to. But um, Chris, was that you that had the 200 errors and discovered?
Yes, correct.
Yeah. Um, so if you had moved the supply point to that elbow and then you ran the calc, it would have run. And when you moved it back to the other place, it didn't. So the error was in between there. That's a way you could have discovered that that elbow.
Oh, I see
That,
what you're saying, like move the supply to just some other point in the system. Hey, it was after the divider and it's running now. Yeah, gotcha.
right. You figured it out. But I'm saying if you had simply the big gun for fixing it is divide and conquer. Oh, this failed to run. Let me try and run something easier. Oh, that failed to run. Let me try something even easier. Oh, that worked. So the problem is between that second and third place, I had the supply point. You discovered it just by starting the process again and saying, "Oh, wait a minute, that's not selected." That's the way you noticed it. Um, I I'm gonna say one more thing and we'll move. We'll keep moving here because I don't have a problem to show you. If you get a problem like error 1308, write down something significant about that error. But most importantly, hover over the last button that you picked before you got the error, which was hydraulic calculations, and hit F1. And that'll bring up the help for how that button works. Scroll all the way to the bottom, and there's a place that says troubleshooting. Click on that, and that gives you a list of all of the ways it doesn't run. And if you look at that list, I expect you'll find error 1308 in that list, and it'll say, this is what went wrong. This is how you fix it. Um, and I've got to leave it. I've got to leave it there till I can really show you one. Um, but that's probably one of the most important parts of the training that I can give you is that there is help for every error that you're going to get. Um, so Brian, I'm sending the presentation request back to you. And click on the calcs. And if you just click on the spreadsheet itself, does that come to the front or do you have to, that got it
Yeah.
to the front? Okay, good. And Brian, I'm thinking, this is familiar. You know where you're at now.
Yes.
This is exactly like you could have typed this in with your eyes closed for a system as simple as this. Um, what you might object to is reference the very second line on the spreadsheet here says node 1 to node 2 is 1 to 2, and then 2 to 3, and then 3 to 4. Someone made those up for you, and that's not the way you would have made them up.
Correct.
But aside from that, I'm saying this is pretty recognizable. The first five, well, lines 2 through 5 are all a diameter of 1.5 inches. Schedule 10, I'm claiming that's a welded branch line. And that each of those lines has a K factor of 5.6 and a density of 0.15 and an area of 100. Those are the operating heads on one of those 3 branch lines. I recognize that again starting at line 17, and I recognize it again starting at line 25. So we've got our 3 operating branch lines represented here in the spreadsheet. Starting at reference at line number 7 is from 6 to 5, and then 5 to 7, and 7 to 8, and 8 to 9. And now we're getting into 4-inch pipe. and 12 to 13 is 4-inch pipe cement lined. So I'm pretty darn sure reference 13 is the supply point. That all makes sense to you, Brian. You've seen this stuff often enough, you could figure that out easy. Dave, does that make any sense to you, or is this the first time you've seen a hydraulic calculation?
This is the first time I've seen a hydraulic calculation.
Okay. The purpose of the hydraulic calculation is to prove that the friction loss, that the pressure required
All
at
the
the
pressure, yeah.
furthest sprinkler, plus all of the friction losses, plus all of the elevations, the elevation pressure requirements
Hmm.
from that most remote sprinkler back to the test adds up to less pressure than what's available at that test point.
At the test point. Okay.
Um,
I'm getting
so
there.
that's an awful quick overview to a lot of detail, but
Oh, I'm sure. Yeah. Yeah.
it does give you a hint what all these numbers are spread all over this
Hmm.
sheet. I'm going to summarize it a little bit further and have Brian pick the button that looks a little bit like a calculator. It's 2/3 the way across the top and it's mostly blue, that one. And that says, actually run this calculation. And that brought up a dialog box that he brought onto the screen for us. I'm going to mostly have you pay attention to the yellow stuff in the bottom of the screen. That's not stuff that we actually inputted. It's reporting sort of summary information of all of this spreadsheet stuff. And it says the number of heads that it found, operating heads, was 15. That sounds familiar, Dave, yeah? That was, we
Yeah. Turn
picked,
my mic back on. Yeah, it does.
yeah, we picked the window around those 3 lines with 5 heads each. And it says there's no added flow, but there's one hose flow. That's our 250 gallons a minute that we put in for the hose. And
Mhm.
then no loops. This is all a dead-ended tree system. If there was a second cross main, then every branch line would be forming a loop between the near cross main and the far cross main. Um, but we're relieved to see number of loops 0 because we thought this was a tree. That confirms it. And then total elevation change. Could you make sense of 24 feet as the total elevation change?
Oh, yeah.
What could you do to convince me that makes sense to you?
I mean, you start underground. Let's say you're so far underground, and then you have to rise up to the
Highest head.
highest head. Yeah.
And our branch lines were at 19 feet,
Hmm.
and our underground was at -5 feet.
Yeah.
That's 24. That's good.
Hmm.
Um, okay, so I'm saying we're going to verify that before we go ahead. If it said 14, we're going to get a real precise answer for the wrong question. So we'll pick OK. And it says we need 405 gallons a minute at 24 psi back at the supply point. And that's 28 pounds less than the 53 pounds that we have, less than what we have available. There's somewhere around 53 pounds, but it's also 53% under the water supply curve. I want to make quick sense of the 405, Dave.
Mhm.
We said the density was 0.15 gallons per minute per square foot. That's what it takes
Okay.
to control the fire. If we put
Is that 0.15 over the 100 area?
yes, and then over the whole 1,500
Yeah. So, but per head, it's
per
0.15
sprinkler,
per 100. Yeah.
right?
Okay.
So if we took aluminum pie tins that were a foot deep and a foot
Yeah.
by a foot and put them on the floor underneath that sprinkler, at the end of a minute of normal operation, we should have 0.15 gallons in each one of those pie tins.
Each one of those by 10. Okay.
Now, I think you and I
Good
both know
visual.
that ain't going to happen. There's going to
No.
be 0.16 in one of them and 0.12 in another one. Um, they're like it can't possibly come down perfectly even over a
Yeah.
rectangle. But the engineers responsible for this whole grand scheme said that that's the engineering target that we're going for. That's the visual for it. And reality's a little bit less perfectly distributed than that. But if you base it on perfect distribution, the real distribution will be good enough.
Hmm.
And so we have 15. So one sprinkler would have 100 of those pans. Each one would have 0.15 in it.
Yep.
If we took all of those and put them in a bucket, that would be 15 gallons.
Hmm.
And if
Yeah.
we took all 15 sprinklers worth and poured them in a bigger bucket, that would be 225 gallons.
Yep. Okay.
1 minute. Um, and then we also said, besides that 225 gallons coming out of those sprinklers, we want to provide 250 gallons a minute for the fire department to show up and use their hose to actually put the fire out. So that's a total of
Okay.
475.
All right.
And I read that wrong. That says we
480.
want
Yeah.
485.
45. Yeah.
Yep. And the difference there is, look at line 2 of this spreadsheet, and over on the right it says the flow is 15.
Oh.
It's the third column from the right.
Yeah.
But the flow in the next piece of pipe is 30.08.
Oh wait. A little
It's
extra.
a little bit more. That's because that second sprinkler has the 7 pounds plus the extra friction loss in that pipe. So there's more than 7 pounds on that second sprinkler.
Mm.
And the
Okay.
third sprinkler has even more than that. So it goes up to 45.4, and then it goes up to 61 point something. So if there was no friction loss at all, that'd be 15, 15, 15, 15, or 15, 30, 45, 60,
45, 60. Yeah.
right? So that's not upsetting at all that theoretically we need 225, but we're getting closer to 233 or something. You like it?
Okay. Yep. I'm seeing it.
Cool.
Hey, Alan.
Go ahead.
David AutoCAD here.
Yes, sir.
I just wanted to let you know I was the other one getting the 200 passes,
Yes.
but I took the
And you
supply.
wouldn't speak up. You wouldn't speak up because you were afraid I was going to make you the presenter.
No, I was just working on it.
Okay.
I moved the supply point to the 90
Yep.
right before the backflow preventer, and it ran.
Okay. So you know that the problem is somewhere between that 90 and the original 90.
Right.
And
Pipe.
David, let's have you continue to go through with this one that's working, because I want you to see the process.
Yeah,
And when
I've
we
seen
get
it. I watched all that.
good, but when we get back to the model and we're done with the calcs, I am gonna have you share your screen. Yeah, I can have Brian do it. We'll look up what is this error 200 passes about.
All right.
And maybe we're gonna run this calc again. Maybe you can move the supply point and have figured out what that's about.
All
But
right.
you've already got a super important tidbit of information. Whatever
Yeah.
it is, it's caused by the piping between that elbow and the original elbow.
Correct.
A plus. David.
Alan, I got a question.
Yep.
This is John. So the OCD in me has got to ask this question.
Sure.
So when I'm looking at Brian's all his values there in the system saying that it's good, it's different from mine. And it
Okay.
seems that everything else is the same. We're using the same drawing, the same calculation, same elevation, same supply,
Yeah.
and it's slightly different. I've got a system is 28.5 psi, and he's got a
Uh-huh.
system 29.13.
Okay.
Is that just something that's going on within the HydroCalc program itself, or
Uh,
is there
HydroCalc is accurate to the 15th decimal place. It's not that.
okay?
15th.
Um,
So that was my question.
okay. No. However, let's go back to a statement you made. You started at the same place, the same system. Dave went, or are we looking at Dave's screen right now?
Oh, I
Dave,
thought it was Brian's.
Not my screen.
we're looking at Brian's
It's
screen.
mine. Yeah,
Okay, Brian, you started today by opening the project I sent out this morning.
correct.
John, did you start today with the project that I sent out this morning, or did you pick up where you left off on Tuesday?
No, started with what you sent out this morning.
Okay, okay, so
So that's
I'm
why I
further
had this
in-
question.
Yeah, we did. We think we started with the same thing.
Right.
Looked at, and I've gotten weary of tracking down a half a pound, John.
Right. And I wouldn't ordinarily. And we don't have to on this call. It just
Yep.
made me a little unsure of the program. Like, wait a
Yep.
minute.
Yeah,
You know what I'm saying?
I do. Now look in column 4 that says pipe type, and
Yes.
convince me that you have all Schedule 10s except on line 14. You've got cement line ductile iron.
That's a problem. Okay, I'm hanging up now.
All right.
Move
When I
forward.
say I'm a little weary, it's almost impossible for two people to do the exact same thing the exact same way,
Right.
right next to each other.
Okay, I did find the problem and we can move on.
Okie doke. So um, so we're just going to pick OK on this um, dialog box. I want to show you maybe quickly two additional things. There's a cover sheet that goes with the printout we send to the authority having jurisdiction, and there's a printout that goes to the authority. So Brian is going to pick on the info sheet button, like right in smack in the middle of those buttons at the top. And we're going to say start a new blank info sheet and fill it in with the current job data. And we're just going to pick OK. And this is pretty much, you'll have to pull it over again for us, pretty much a list of the information that is one of the pieces of paper that we submit to the AHJ. And I want to just fill in, the job name is fine. Under design, where it says remote area number, let's put RA1 in there. And two boxes down from that is occupancy, put OH1 in there. And on the next line at the right says area of application. Let's put 1500 in there. Most of the rest of the information is pretty straightforward to fill in. We're not going to take time to fill it in, but it's your place to put that stuff in. So we're going to pick OK on this. And then we're going to use the final printout button, which is 3/4 of the way over on that thing at the top. It looks like a little tiny printer. Go ahead and pick that.
Gotta write an RFI right away.
Okay, we got an open mic. And maybe that's you, Brian.
No, it's not mine.
Might be Dave.
Yeah, it's getting a little loud around me right now.
Yeah, okay. So let's just leave it on final, and whatever that says, autosave the WXF, yes, and pick OK. And there's a cover sheet. Okay, we have to fill this in, and it says print the cover sheet, print the summary, print the info sheet, and the final calculations. Normally, this is just fine the way the defaults are, so we're going to pick OK. And here's the cover sheet. And you see, this is Brian doing it, so it's got his company name in there. And we'll scroll down to the next sheet. And this has the information we typed in a minute ago. We're on sheet 2, yeah. So RA1 is in there, OH1 is in there, the 1,500 square feet is in there. And I mostly want Dave, you to see this. These are the pieces of paper you're going to submit with your drawings to the authority having jurisdiction.
Okay.
And in place of just a note that said Brian said it works.
I was going to use that one.
One more sheet. Yeah, this one has, if you look on this graph paper, Dave, on the left is point C1, which is 55 psi at zero flow, and C2 is 1150 at 44. Do you see those 2 points on this graph? C1,
Yeah, I see him. Yep.
C2. Those are those numbers we put in for the water supply. And piece, when we said define supply.
Yeah, way back with that generic annotation thing.
Yep. 55, 44, 1150.
Yeah.
This is graphing those 2 points and drawing a straight line through it and saying, okay, well, if you had 800 gallons, if you needed 800 gallons a minute, you would be getting 50 pounds.
50 pounds. Okay.
If you needed 1,600 gallons a minute, you'd only be able to get 35 pounds.
And that's PSI pounds.
Yes.
Okay.
Yes. Yeah. And then that D1, D2, D3 stuff is if we needed no gallons a minute, we would need about 10 pounds just to get any water at all out of the sprinkler heads. That's the 10 pounds from elevation pressure. Okay. Until there's enough pressure to raise the water to 24 feet above the supply, you're not going to get any water. Then you get more and more water up to, and it's really small reading, but I think that says 225 or 220, 230 or something.
I got 235, yeah.
And then that D2 line is 250 gallons for the fire department. Okay, enough hydraulics 101, but thanks everyone for your patience without trying to describe that. We'll close this. And we'll close this. Brian, I'm promising you that it's going to get saved if you made any changes in here. Oh, I did have a slide about, did you close it already? Good. 28 pounds or 30 pounds safety margin is a little much, you think?
Yeah.
We might get away with the branch lines being 1.25 inches instead of 1.5 inches. So let's click in the third column for diameter at the first one that shows up 1.5, and then pick on the binoculars. And we're going to say change 1.5 to 1.25, replace all. And now it's calculating with 1.25 inch branch lines. It just reminds us it did 18 of them. We'll exit. And then we'll run that calculation button again. The yellow stuff should still be exactly the same as before. So we'll pick OK. And now we're 24 instead of 30 pounds under the curve. So we still have lots of safety margin. And we could play more, but I just wanted to show you, you've got this spreadsheet that you have control over, and you can say, what if this, what if that, what if the other thing, before you return to the calcs. So we'll pick OK. Any questions on that before Brian and I close this out and get back to the model?
Yeah, sorry, what did you click to do the change all again? Wait for a second there.
First, we started in the diameter column, and we clicked on the first diameter, the first 1.5. And then there's a binoculars button, and Brian's hovering over that now.
Gotcha. Yep, perfect.
Got it?
Thank you.
Okay. Anyone else?
What about loss for valves? Do we put that in manually, or is that?
You could go hunt it down and put it in here, but it's in our slide deck. We're going to go add that to the valves in the model, and we're going to run the calc again with that in there.
Okay.
But this is the standalone hydraulic calculation program. So you could say, darn, I forgot to do that in the model. I'll go find it and put it in here.
Changing things in here does not change the model, correct?
Does not automatically change the model. And the diameters are about the one thing that you can use to change the model. And I've found that even though I can, I'm not always thrilled that that's the best way to do it. So I'd say your statement is 95% correct. And it does not change anything automatically. You've got to tell it, go look there and get the diameters I used there. And we're going to do that in just a few minutes. Other questions before we leave here? Okay, Brian, let's do it. We'll click the X, and you made changes, you changed it. They will be saved in this file when you pick the X. And go ahead and say yes, it's been a while. And now that fuel gauge and the annoying questions are all gone, and we've run the calc. We're going to click on Return to Revit. And that's two things are going to happen. The first, it put hydraulic reference points on that we'll see in a moment, and it's asking us to park an answer block. And I'm going to say pick up and to the right of the water supply information you've got there. Yeah, click there. So there's the answer block, and you'll see in the answer block is the 1,500 square feet and the RA1 and the pressures and flows that we calculated. I'm disappointed that it doesn't say OH1. That seems like it should have shown up. However, it's just a generic annotation. If you click on that dot next to occupancy, right there, click again, you could type OH1 in there.
Mine doesn't show the total required pressure. It shows the safety margin, but doesn't show either of the two above that.
Then I'm thinking an update to the toolbox would do that. That block reports that generic annotation has changed a couple of times with the toolbox. Are we? Who asked that question?
Michael, it shows the things that are just not, the values aren't in.
Just still no values there. Then do you still have the hydraulic calculation open? Did you sneak back to Revit and pick this?
Yeah, I'm back in Revit.
And the calculation has been closed?
Correct.
I don't know that one, but we're going to run the calc again. Let's watch it again after we run the calc a second time. Yeah, that's gee, I don't know. Let's do it again. But we're on our way to doing it again. So let's keep going. Fair enough. That being said, there's one other thing you could try right now. You have the box on the HydroCalc ribbon. Fourth button from the end says Update Demand Info. Do you see that button?
Yep.
Click that and then click on that generic annotation. There's no reason we can't do that too, Brian. Click that Update Demand Info and then click on that box.
Well, it took away the OH1.
Yeah, I think we'll pay closer attention when we get into the calc, but I'm thinking that's blank in the calculation file. That's what's making me think that's why we missed it. I saw you type it, but I don't think we hit enter or something, Brian. We'll look again when we get there.
It was on the info
Is
sheet.
it pulling some of that information from the actual the cover sheet information, or is that pulling it from the calc itself?
from the WXF file, which includes the cover sheet and all the input.
Okay.
Okay. Let's get back to having some more slides here. I want to go to slide 20. We probably have a couple of review ones. Slide 21. You remember we went over this, Brian? If the continue button is grayed out, or if that information isn't filled in, then switch back to the classic or the custom input and do load default supply, load default supply, load default supply, and then switch back and fill it in. So that's a reminder about that. Let's go to slide 22. When you're in the calc, you say run the calc and you check the yellow stuff, and then you get the answer. And in slide 23, if the answer says you're not using enough pressure, you've got the option of changing things, mostly diameters. You could conceivably change, oh, I messed up and I didn't put the density right or the area right. Or you could say, I don't have the other fittings, I forgot them. You could put those in. So you can make changes in the calc while you've got that open. And then slide 24 says that when you get, slide 24 says, Dave and some other folks are not as familiar with HydraCalc as a standalone program as you are, Brian. And on the C drive in HES HydraCalc Ver 50 docs, there's a document called HydraCalc Tutorial 1 that is a system very similar to this 60 by 80 foot building, and it goes through step by step inputting all of that information. It sounds like a drag. I think it'll take you most of an hour. But you could input all of that information directly from a napkin sketch into the standalone program. And that's a really good exercise for those of you that haven't been exposed to this program before, just to get an overview of the different things you can do in there. So now let's go to slide 25. When you get back, you get reference points. We haven't seen them yet, and you get that answer block. And we're, I think, on to slide 26, which, yes, is yellow, which is great news, except by the colors, we're 1/4 done with our slides, and we're 1/2 done with our time. Does anybody need a quick potty break? We'll give you 7 minutes if someone will pipe up and say, yeah, I need that.
Yes, sir.
Yeah.
And we'll start again at 11:50.
Thanks.
You bet. I'll be back at 11:50. Brian, are you back?
Yes, sir.
Cool. Well, let's get right into it. Um, we've run a calculation, and it needed operating heads, connected model, and a water supply. We're going to run the calculation again, and we're just going to get a little bit fancier with what we're doing. There's a few collecting informations from this previous calculation in the yellow stuff here, and then there's a little bit of getting ready for the next calc and running the calc a second time in the yellow slides here. The first slide has to do with we ran a whole calc and we don't even see any pipe sizes on the drawing. Tag pipes is the way to get pipe sizes on the drawing. We used that a little bit the other day. We're going to put them on this working view. So just do WW and pick a pipe. And there's our reference points. That's cool. We're going to use them again in a minute. But WW, pick on a pipe, and then type TP for tag pipes. And I'm going to have you use dynamic length tags. It's in the upper left-hand corner, that third one. Do you see the difference in the picture, Brian?
Yeah.
I'm having you use these ones because they're the most magic. If you change the diameter, poof, the diameter changes. If you change the length, poof, the length changes. Like you move a pipe, well, the pipes that got longer got a bigger dimension, pipes that got shorter got a shorter one. If we use center to center, it's got the tag pipe process to go calculate that. If you move stuff around, you need to run tag pipes again to get those
Okay.
updated. That's why I want to do the dynamic. And click on the Run Cleanup on selected tags. That's going to tag the pipes, and then in a second process, it's going to say, oh, I could move some of them around to not be in each other's way. And now just pick Continue. And click on, and it put dimensions on. And do you see the 0'6" at the north end of the welded branch lines? Do you see how they're
Yes.
right on that pipe? Now click Move Regular Tags. This is the cleanup process. And it looks around and it says, oh, that one's a little crowded. I'll move it out of the way. Do you see what happened there?
Yep.
And there's a box at the right end of the cross main that says, I did my best to clean stuff up, but there's some stuff in here that I'm not happy cleaning up myself. I just wanted to make you aware of it. So if you click on that box, you could erase it. Just hit the delete key. And if you zoom in, the 4-inch, 3 foot, 6.5, maybe you could click on that and just use the right arrow to smudge it to the right a little bit. And it looks like the 1.5, that one you could nudge up north a little bit. Okay. So he was just drawing your attention to that one. And I'm sure John is going around and moving all of those things. And there's some cool stuff on the way for all of this dimensioning, but I don't want to turn this. This is a calculation process here, so I want to keep us after the hydraulic calcs. So let's go to slide 26, 27.
Hey, Alan,
Yep.
is there another way to get the TP? But for some reason, my shortcuts don't work.
Okay. Yes. You go to the Hydra. It's on the HydraCalc ribbon and it's on the HydraCAD ribbon.
Okay, HydroCalc. I'm looking at it, but I don't see
And
TP.
okay, Brian, pick on the HydraCalc ribbon. Yes. And I'm lying to you. It's on the HydraCAD ribbon.
Oh, okay.
And hover
See it.
over tag pipes and tell me if when you hover over tag pipes, it says parentheses TP or not.
It doesn't. No.
Okay. So we're going to get that there for you because we're going to do shortcuts all the way through. So
All
type KS. That's the keyboard shortcut for keyboard shortcuts.
KS. All right.
And that brings you up a dialog box. And
Yes.
Brian, you and I can do this also. Go ahead and save project, Brian. But there's no harm in our doing it again. So we're going to do KS. And then in the lower left-hand corner is import a file or import ...
Right.
Click that. Then drive to CHES, Hydratech for Revit. Data, Hydratech for Revit, data, setup,
See
HES, Hydratech for Revit,
data
setup.
setup.
And there's 3 keyboard shortcuts ones there. Pick the third one. It's the one with the most recent date.
Okay.
Then pick open. Then if you trust me, pick overwrite. If you have done all kinds of customization in Revit already, pick merge. And then close this dialog box and then hover over the tag pipes button and tell me if there's cause for much rejoicing.
Yeah, it's there now.
All right.
Thank you, sir.
You bet. So on slide 26, I wanted to show you putting those tags on. On slide 27, we're going to talk about we changed in the calculation, we changed 1.5 to 1.25 and I want to show you that there's a button to take advantage of that. And then even though there's a button to take advantage of it, I feel like there's a better way to do it. We're going to do that also. But first, go back to Revit and zoom in on the calculated area, or so that we can see the calculated area. And you see those diameters are all 1.5. Zoom out just a little bit so we can still read the 1.5s. Perfect. That's perfect. And now go to the HydraCalc ribbon. And there's a calculated diameters or CD. Pick that. And don't go anywhere, Brian. You notice the 1.25 showed up?
Yep.
Cool. But look at the 4th branch line from the right, from the left there. How come that one's 1.5?
It's not in the calculated area.
Exactly. This button is just a little, it is by its nature too literal. It says if it's in the calculation, make the drawing be like that. But it's not all of what we want to do. So I'm going to have you pick the undo button and get the 1.5s back. And instead, I'm going to have you look in the project browser. There's a plus sign next to schedule/quantities. You're right there. Click that. And then there's a pipe size and type schedule. Yeah. Click that and open it. That's it. Now, that's a little bit too small to read, Brian. Yeah?
Yep.
You know how to make it bigger?
Used to. It's been a while.
Well, I was always pissing and moaning that there was no way to zoom or anything, and it turns out there is. You just have to be a web user, if you hold the control key down and you roll the mouse in and out, it'll zoom in and out. And that's not like unique to schedules. That's like a standard feature for when you're using southwest.com or hydrotech.com. If you go to the web browser, that scroll wheel makes stuff bigger and smaller. Who knew?
I think
So
that was only a Revit 22 or 23 new feature.
is it really?
Yeah.
Well, maybe there was no way, and then when they did it, they did it using sort of a
Yeah.
modern standard. And
Yeah, 'cause I remember
about it.
20, Revit 20, Revit 21. Yeah, it was always so small. Yeah.
Yep. So it was lost on me for the next couple of years after that because I didn't think to use a web standard for that. Okay, cool. And do you see, Brian, that the third line down says there's 36 pieces of pipe, 1.5 inch lines welded.
Yes.
You click on that 1.5 inch, you can dial in 1.25 inch, and then you could close this schedule.
We want to do both of them.
We could do the lines threaded also. And now close the schedule. And now we've changed them all. How's that for cool?
Nice.
Alrighty.
So much.
What button is that again?
We went to the schedule. That schedule was the pipe size and type schedule.
I just double clicked it. And...
Right. How do you get that to pull up?
Double click on that in the project browser. You find the schedule. Tell me you're finding it, or we'll make you the presenter.
Yeah, I see the schedule on the project browser.
Okay, then double click on it, and that should open it. Yes? No?
What pipe fittings? Pipe schedule?
Pipe
schedule?
size and type schedule.
Thank you.
Cool. All right. I'm going to go on to slide 28. I'm going to talk my way through this. The threaded branch lines are more commonly telescoped sizing wise. So you have maybe 1, 1.25, 1.25, 1.5. I just want to tell you about this and keep us moving. There is another button that says resize pipe, and with it you can define what a branch line is. You want to be careful to define just the lines threaded pipe as lines. Everything else you want to be mains or underground. And then that brings up a schedule where you can tell it, I want 2 heads on 1 inch, I want 4 heads on 1.25 inch, I want 100 heads on 1.5 inch. And then it'll resize the threaded branch lines that way. But we're focused on getting another calc here, and it's not even in that area. So let's move on to slide 29. And here I want to describe how you could change the main. You could change the main the way we did before with the pipe size and schedule, the pipe size and type schedule, but you could take a run of main and change it also. And again, I think I want to do it and not do it, do it and undo it. So I show you that. Go back to the Revit model. Find the cross main. That's, I think, a little north of what we're looking at right now. And I want to show you the WS button. So type WS and pick on the cross main. I think you did. Escape. We had those other ones selected. Escape. Okay, nothing selected. WS and pick on the cross main. Do you see how it got it got the cross main, including going around the elbow. This is like the walker, except that it won't turn a corner at a T. So it's a way of getting a run of pipe. One more illustration: escape, escape, escape. Do WS and pick on one of the branch lines. Okay, so by example, Brian, can you see what this is doing? It's doing a run of pipe. I'm telling you that the riser nipple is not selected. And obviously beyond that's not selected. Got it?
Yep.
Is that based on pipe type?
I don't believe so. I think it'll switch pipe types, but
Okay, all right. So if I
yeah.
change the pipe type halfway down the main to another type of main, it would still select it or something?
I believe, I'm pretty sure. That's
Okay.
a great question. Probably not terribly critical. If it
No.
didn't, then just do WS again and do the other side. But I'm pretty sure it doesn't. It stops at T's, and it stops at dead ends, and it stops at valves.
Okay.
All
right. That's a better explanation for me. Yeah. Okay.
Sure. So you could select a run of pipe and then just change the diameter from 3 to 4 or 4 to 3 or whatever. And we're going to keep going. We're not going to change it. I just wanted to show you that's available to us. So let's go on to slide 30. Cool. Slide 30 is great because it's a summary. In the order of things, I said, oh, look, we did calculated sizes, but I got a better way. So we used the pipe size and type schedule. So we're experts at that now, and we'll go on to slide 31. And now, who was it that offered S101, S102, 103?
I just mentioned that's how I normally tag mine when I do that.
Brian, that's your plan. Cool. So we're going to go tag them that way, and we're going to use the R button or the renumber reference points button, and use your scheme. So let's go back to the CAD model, the Revit model, and on the HydroCalc ribbon is a button that says renumber reference points. Right there, pick that. And then type S101. And what this thing is going to do is increment, and it's incrementing the number at the end, the thing that's at the end. So continue, and there is a reference point at point 1. Click on it. It becomes S101. Then click on 2, then click on 3, then 4, then 6, not 5. Okay,
Yeah.
we screwed up. We're going to come back and fix that one. It's on mentally onto 6, which I want you to go to 14 and do. Escape. It's screwed up now, Brian. You with me?
Yep.
Okay, so start the renumber reference points. Type X1. Instead of S108, make it X1. Continue. And now pick on those 3 that you screwed up. S105, S106, and S107. Okay, now escape once and type in S105. Pick continue. And what currently says X2. Wait a minute, why does 105 exist? I thought we got rid of it. Oh, escape, or okay, and escape. There, and now start over. Renumber reference points. And put S105. And click where it's X2, that's 105. Then what's X3? That's 106. And then that one's 107, 108. That one is 109, and go past the cross main. There you go. That's 110. And now go down that one, 11, 12, 13, 14, 15. Escape once. And I think you said A101 for the riser nipples.
Yeah, I usually, what I'd do is I'd do like B101 for the top, A101 for the bottom. Then
Okay, so let's type B101. And click where it says X1, that's the top. And then 18 is the top of the next one. And 24 is the top of the next one. Now escape and A101. And then what currently says 7. And zoom way out. I think 11 is, so 10 and 11 are like the top and the bottom of the riser. And 12 is getting to the underground and 13 is the supply. You might want to just say BOR, TOR, backflow test. Or do you want, that's the one that says 10. And escape, escape, escape. You can use this tool that way if you want, but you can also just do them right on the block. So cancel this. And just click on 11 and click it a second time and type BOR. Yeah. And then click on 12 and click on it again. And you can say BKFL or UG1.
I'm not sure why, but I don't have the TOR BOR nodes.
Yeah, I'm not sure why either, and I'm not going to worry about it.
Okay.
I will show you if you really want a reference point, and it's if the diameter or the pipe type or the flow changes, the computer is automatically putting a reference point. If none of those change, it doesn't put a reference point. I think maybe because Brian added that hose, the friction loss for that valve in there, it put reference points on both sides of it. Before I lose my train of thought, though, let's click on 13 and make it say test.
Are these the reference points in the calculation, like Excel looking sheet, when you said like 1 to 2 and 2 to 3? And
That's right. That's correct. And we're
okay,
changing them. And when we
okay,
run the calc again, it's not going to use those ones. It's going to use these ones.
Alan, quick question. If you
Yep.
move a annotation, say top of riser, so it's clearer,
Yep.
is it still associated with the top of a riser?
Absolutely. Way
Okay.
better than AutoCAD. In AutoCAD,
Much better.
we were using the location to match that up.
Okay.
I want to show you a couple of things. Let's in another operation. Brian, let's zoom to the connection of the feed main and the cross main. And the diameter, the flow, and the pipe type, none of that changed. So it didn't put a reference point at that elbow. But we're going to. There's a button called single ref point. Click that, then click the elbow. And drag that off to the side where it's readable. And let's just make it A104.
yeah,
So You can number reference points ahead of time, and they will be included and made part of the calculation, Brian. But that's not as quick as, and it's not as reliable as, oh, what the hell, just put reference points on, and then I'll tell you what I want them to be. Does that make sense?
Yeah.
So workflow wise, I'm very likely to identify operating heads, to make sure I have a connected model and I have a water supply. And then I do the walker, I run the calc, I close my eyes, I don't care what it says, and I get back to the drawing. Then it puts a fake answer block and it puts reference points on. Then I renumber the reference points and run the calc again with things that are easy for me to recognize that I care about. So I wanted to show you something else. If you click on that elbow and look in the properties of that elbow, down under, I think it's under fire protection. There we go. You see it says hydraulic reference point?
Yep.
So that's how we get away with, you can move it anywhere you want. The value is a part of the elbow. It's not unique to that block, and that block has a location that lines up with the elbow. It's a property built right into the fitting. Another cool thing about that is, let's go open up that section that looks at the riser. And pick on all reference points. All reference points is, it's a button. You're on the HydroCalc ribbon. There you go. It's in the annotate panel. And no, when I said annotate panel, and then you thought I meant annotate ribbon. No, it's on the HydroCalc ribbon. The panels are those tiny words underneath all the buttons. Find the tiny word that says annotate. Okay, that gets you down to like 4 buttons. One of those 4 buttons is all reference points. And I think in this case, we got gypped because there's already a reference point there. I think I'd want to go to that other section anyway. Go back to the floor plan. Yeah, close this and zoom out a little bit. That's the section I want to go to. And perfect. Okay, now do all reference points.
Nice.
And is our new one, A105, is that on there also?
A104 is, but
right. That's the one I meant. We put A104 on, and we put it on that elbow, and that elbow is in this view. And when we said all reference points, it says, oh, there's an elbow, and it has a reference point. I'll put one there. Good deal?
Yep.
Okay, so let's go to slide 32. And I told you that we could mark the most remote area with a filled region. And I said later, and now it's later, so I'll show you how to do that. So go to back to Revit there. Zoom in on our 15 sprinklers that we're interested in. And in AutoCAD, there is a Hydrotech button that says, tell me the distance between the heads and distance between the lines and how many heads, and it draws a polyline for you that you can sort of smush around and stuff. In here, Revit already had a legitimate tool for that, and it's in the Annotate ribbon. So let's go to Annotate. Ribbon. So I'm going to slow you down, Brian. When I say Annotate ribbon, it's the names at the top. When I say Annotate panel, it's the names at the bottom.
Okay.
Right? And unfortunately, there are plenty of duplicates. There's a modify ribbon and there's a modify panel on some of the ribbons. Okay, but on the annotate ribbon in the detail panel is region. And there's two kinds of regions, filled region and masking region. We want a filled region. And this is like drawing a detail line, and we've got choices for how to draw it. We can draw it one line at a time, or we could draw it as a rectangle. Do you see? Most of the things are grayed out, but there's a big red X and a big green check mark 3/4 of the way across the ribbon buttons there. The green check mark says, I'm done telling you this outline. The red X says, I'm chickening out. I didn't want to do this anyway. But to the right of that, currently it says you're drawing this outline a line at a time. Go one to the right of that. It says, I want to draw a rectangle. Click on that and start your rectangle in the lower left-hand corner of the building, right? Can we take credit for that, or do you want to take credit for the inside of the walls?
I do inside of the walls.
Okay, so pick at the corner of the inside of the walls. There, perfect. So that's our starting point for our rectangle. And as you drag your rectangle up, do you see it's reporting the length of that rectangle?
Yep.
And have you memorized what 1.2 times the square root of 1500 is?
Is it 40?
47 something.
Yeah, and then by 36 something.
Yep. So, right, you know where we're going, but you see the 50 feet?
Yep.
If you got less than 47, you would need that other head anyway, so you go to 50. And if you go in the other direction, you're going 30. And if you click there, we're there. And then click the green check mark. Okay. So Brian, there's an outline of our most remote area. Do you love it?
Yeah.
You would use that? John, would you use that? It's an honest question. You love it? You would use that? Or you say, nah, I don't ever draw it that way. I want my crosshairs going the other way, or it's too busy, or it's not busy enough.
I would make a region and do it around the area, but like 10 inches wide. So I'd offset that region.
Yep.
Makes sense. 10, and so it would just kind of put a hatched area around it, but not over it.
The hatching doesn't go through everything. The hatching
That's correct.
is just around the edge. Okay.
When it's too busy, that's what I do.
Okay. So I want to show you that. If you click on that thing, that's the annotation. Perfect. And now click on Edit Boundary. That's on the open ribbon, 3 from the end. We're basically back where we were defining the outline. Pick rectangle again now. And pick a starting point in the lower left-hand corner, but that's 10 inches inside in both directions. So from that corner, go up and to the right 10 inches and 10 inches. Don't start there. Don't start there. Move in a little bit.
Like that?
John, you tell him. Where do you want to start? You don't know. Move a little bit to the right yet. Start where you... Yeah, and now move up that much.
Sorry, I was muted. Yeah, start in the corner, and then you can come over where you want it to be, and it shows you.
Yeah, so start there. Click there, and now click the equivalent point in the upper right-hand corner. Nope, inside, not outside. There. Click there. And now the green check mark.
Ah.
John, that looked pretty good?
Yeah, that's the way I typically will do it.
Okay. I don't want to go too detailed, but you can draw the inner box with an invisible line and get the hatching without getting that extra line. Or you can draw the one and only box with a thick line or with a dotted line. So some people don't use a hatch at all. They just use a fat dotted line. Um, I maybe want to say Google filled region and get more details about the variables you have on that filled region. But we got pretty close for you, John. You're happy?
Yeah, it looks good.
Excellent. So we're going to go on to slide 33.
Real quick on that square, does that have to be
Yeah.
perfect, 47'6" by whatever, or just close?
It means to be an even number of sprinklers.
Mhm.
The line wants to be halfway between two lines of sprinklers or
Yeah.
between two heads. And then the total area has to be equal to or greater than 1,500.
So you're trying to get a 1,500 square foot area is what that is.
1,500 plus. The standard says no less than 1,500.
Okay.
And
That's
it
what.
implies,
Okay.
and it's not 4.5 sprinklers long ever. It's
Yeah.
4 sprinklers long, or it's 5 sprinklers long, or it's 6 sprinklers long. It's not 4.5.
Okay. I understand. I don't know if that had anything to do with the design or calculations or anything.
No, the design and calculations at, at most will say all the ones inside that area we're going to use.
Yep.
The way we calculated it, it was I told it those 15 sprinklers, and the purpose of this annotation is absolutely nothing except to note which 15 we use.
Which 15 it is. Okay.
Yeah. There's no relationship other than that. So equivalent lengths. We want to go back to that section that showed the riser. And then we want to go to slide 33. And that says there's a button that you can get to by typing EQ, or it's the equivalent length button on the HydroCalc ribbon. Um, and it allows us to add fitting equivalent lengths. So Dave, Hazen and Williams are 1900-ish mathematicians that came up with this shorthand formula for the friction loss through a pipe. And they said, we're all proud of ourselves. We've got the friction loss for a pipe. And somebody said, well, how about an elbow? Is that a pipe or what? He said, well, there's more friction loss in an elbow than there is in a straight piece of pipe. So we're going to give you a table that says when you get to an elbow, count 10 feet of pipe instead of nothing. When you get to a T, count 20 feet of pipe. And later, when the backflow people made their thing, they had to come up with what's the equivalent length of a pipe to calculate the friction loss. So they actually measured the friction loss and then backwards calculated that formula to figure out what equivalent that thing would be. Some of the tests didn't work out well. Pipe implies that more or less twice the flow gives you 4 times the friction loss, and 4 times the flow gives you more or less 6 times the friction loss. It's the 1.85 power, not the square, so it's not exactly 4 times as much. But when the backflow preventer people tested their valve, it didn't follow that scheme. So they said, we're just going to give you a chart. It says if it's this flow, this friction loss, this flow, it's that friction loss. So there's two different kinds of equivalent lengths, a curve and an actual equivalent length. We're going to use it on our backflow, which uses a curve, and we're going to use it on the butterfly valve, and we're going to use it on what I'm going to call the swing check valve. And slide 33 is our reminder of the way to get into that, and we'll go actually do it on the Revit model. So let's switch back to the Revit model and find the HydroCalc ribbon. And on the HydroCalc ribbon, we're going to click equivalent length, or we're going to just type EQ. It's right there. And then pick on the butterfly valve. And Brian, this is a very familiar box to you.
Yes.
And in this case, I'm going to have you just pick the B that says NFPA 13 butterfly valve and pick OK. And then pick that equivalent length button again and pick on the shotgun riser. That's it. Yeah. And let's just use S for a swing check. So scroll down. Yeah, it's possible if that's a reliable has a cut sheet and they told us equivalent length, but we're going to use a generic S for the swing check in there. Pick OK. Then equivalent length one more time and pick on the backflow preventer. And this one does not have a fittings length, so we're going to go to curves and scroll way down to Wilkins 350A. There it is. And pick OK. And we could have done that, maybe better have done that when we first put the valves in, and it just remembers forever. And then our first calc would have had those in it. But they're there now for when we run the calc again. So let's switch to slide 34. And this one I'm just going to talk about. There's a feature for the sprinkler where you can click on the sprinkler and say, show me a box that allows me to measure to the next closest branch line in each direction and to the next closest head in each direction. And if there's walls involved, to the nearest wall in each direction. And it'll take all of those numbers and find the maximum S distance, the distance between sprinklers, and the maximum L distance, the distance between lines, and multiply that S by that L and report to us the coverage area of that sprinkler. Dave, in our sample, all the heads are 10 feet apart in both directions. S times L is 100. But in an office building, that's seldom the case. And you may want to not just say they're all 225 square feet. I may want to measure each one so that I'm not flowing more water just because. I want to flow just enough water to get that density times area requirement to be met. Anyone have any comments or thoughts or questions on that? Cody, I see you're called in. Can you hear me?
Yes, sir.
Cool. Is this an idea that you've used in the past when running a calc?
Which part of it?
The idea that you're not necessarily just saying this head's good for 225 square feet, so I'm doing a calculation based on 225.
It depends. It depends on if I want extra safety factor or not. If I throw in the extra feet, if I want some kind of wiggle room in the actual installation, it depends.
It depends, but there are situations, I think I'm hearing you say, there are situations where I really need to pay attention to this. And there are other
Oh
cases
yeah.
where I'd prefer not to be bothered with this, and the extra that I'm delivering is good for flexibility in the field.
Yep.
But this is for that situation where you've got a very poor water supply and you're just barely scraping by to get the system to work. You shouldn't overcharge yourself for that calculation area. This is a way of measuring them individually. So that idea you've used before. Um, how have you dealt with it in the past when you had to say, I can legitimately claim this head's responsible for 160 square feet? What have you used? What tool have you used to calculate that 160 square feet?
Well, HydroCalc. I mean, you can throw in the actual area per head in HydroCalc, and it can adjust on its own based
That
on the
head area,
spacing and the
that head area
density.
box.
Yep.
This is it. So I'm not going to show it to you now, but I tell you now, you use it later. This is that head area box, Cody.
Yep. That makes sense to me.
Cool. The cool thing about it is after like you use that box and then you say I'm done, it writes the area next to that head. That's pretty cool. But if you say, did I
And
really pick the
that's in the
wall?
non-print layer, just like HydroCAD.
Right. In here, it's a property of the head, so it's non-print
Okay.
unless you
Cool.
put an annotation on it. But if you pick on the head, you could turn this box back on and see that you actually measured the walls and the heads and the lines that you meant to do. Whereas in AutoCAD, the only thing we remember is the answer. Okay, so I'm going to move on to slide 35. And we're going to use extra coverage to force the most remote area. This is another one I'm going to just talk about. But in Hydrotech for AutoCAD, there was a button called Most Remote Head, and it looked like Mr. Head. And if you used it, it put a lighthouse on the sprinkler that you pick on. And that lighthouse would say, I don't care what the mathematics say. I want the calculation to start at this lighthouse. In Revit, um, we said the standard says start at the hydraulically most demanding head, and we do that. So the beginning of the calculation is at the head that's most hydraulically demanding. If your line spacing is not even like we have here, and there's 3 heads on the absolute furthest line and 5 heads on the next branch line, the hydraulically most demanding is almost sure the head on the end of that second branch line. Um, and if the calculation starts there, it's technically correct. It's technically the most correct way you can do it. But you could get an AHJ that says, what's up? How come you didn't start at the most remote head? Meaning the furthest head on the furthest line. Does that scenario play into your experience at all, Brian?
Uh, yeah, I mean, with the hydro, I just note it, and it usually sometimes it'll switch up once you run the calc. It'll when that bar pops up,
Yeah.
it'll
Say the
switch the remote
head.
head. It will detect it through the calcs and switch that
Right.
final node.
Right. But when you're reading the final calculation, does it always start at the head you want it to start at? Or do you not really care? It starts at a head and it's approvable, and that's that.
Yeah, when I set my calcs up, I always start at the furthest head on the last line.
There's my point, and that's why this slide is important, Brian. We're not necessarily going to start at the furthest head on the furthest line.
Yeah.
We are going to start at the hydraulically most remote head.
So, Alan, what you're saying is if you had one head on the most remote line, most remote front out,
Right.
but it
Furthest
happens to
one
be
out.
in a little closet which would not
Right.
be in our calculated area. That's what this is for?
No, no. If it was everything you said up to,
Oh,
it's not in the most remote area. I'm saying for a head that's on that furthest line, it's part of your 1,500 square feet, but it happens to be fed all by itself off of one pipe. It's not. It's not hydraulically the most remote head. It's got more water than it could possibly need.
I got you. So it just happens to be geographically the most remote.
Geometrically, the furthest head.
Yes.
And and Brian is saying he'd like to start there. It's the furthest head on the furthest line. And he'd like the calculation to start there.
Makes sense.
Our program will not. It says, no, Brian, that's not the most remote head. It might be the furthest, but it's not the most remote head. We are not starting there. This slide says, how do I trick it into starting there anyway? You see what I'm trying to let you do?
Yeah.
You're creating the most remote head, in a sense.
Right.
Okay.
And the way I'm going to create it is I'm going to click on the head and I'm going to look in the properties, and the head's going to say 100 square feet, and I'm going to change it to 400 square feet. It's now the most remote head.
It's the most remote because it's the most hydraulically demanding one.
It's the most demanding. It needs 400 square feet. All
Okay.
the other ones need 100 square feet. Well, that's the hardest.
Does doing that change the calc though by changing the actual coverage?
It changes it a lot. So when I get to the calc, I'm going to change 100. I'm going to change 400
back to
back down to 96 or whatever it is. That's the trick to forcing it to start at the most remote, to start at a particular head.
Okay, and I see you just change it in the HydroCalc program after the fact what it has to be, and then run calc again, essentially?
Right.
Gotcha.
I will be reminded to do that because I guarantee you, if I change that from 100 to 400, when I get to the calc, it's going to say you're 800 pounds over the curve.
Yeah.
And I'm going to say, oh my gosh, what's this? Oh, I remember I made that first head be 400. I'm going to change it to 100 and run the calc again. Got it? It's easy. It's a trick. It seems like it's harder to describe than it is to do it or to make it happen. But it's a way for you to say, I want the calcs to start at this point. Just make that area be big. And when you get into the calcs, make it be real.
Go ahead, Chris.
I was going to say, and that's essentially the goal would be just to say, hey, make sure path 1 is this head, because you could just renumber it if you wanted to, right? Anyway.
You're correct. But path 1 is this head, and the first line in the calc is this head. That's what it's for.
So is there no way in the software itself to say, put a checkbox on all these heads to say, but only have one check that says, I want this to be the most remote? Instead of changing the coverage area, could you just add a property to the head to say, hey, this is the most remote?
We could do that. We didn't, and that's why I'm telling you this is our trick.
Okay, then that's okay.
Yeah. Okay, let's go on to slide 36. And we've made some changes, and I want to rerun the calc. And when we do, I will have us take note of the fact that the reference points now reflect A101 and S101, and that the equivalent lengths are what they are meant to be. Let's go run that calc. Back to the plan view is probably the best place to start. And do the walker, and then do the walker again, and then start the calculation. And the walker the first time gets you this, depending on where you pick, it gets you the sprinkler system, and the walker the second time gets you the underground. I'll just warn you ahead of time, the hatch pattern in that annotation sometimes makes the pipes a little shy. So the pipe you pick more easily might be outside of the remote area. But I see you had no problem there, Brian. You selected pipes with the walker, you selected them again. That makes a connected model. You've got operating heads, you got a water supply. Let's start the calc. David, I cheated you out of the um, error checking that I was going to brag about. Um,
So after you run it, do you hit launch or do you hit hydraulic calculations again?
Launch simply independently loads
Okay.
the standalone program. So not that. You want to pick hydraulic calculations.
Okay. Why? I mean,
And look, this is all filled out for us. The Lord be praised. We don't have to do that load defaults apply thing. So you can just pick continue. And yes, it's there from before. We're going to write over it. Yay, there it is. So I'm saying much more readable. S101 to S102 to S103. I put them on. I know exactly what that is. And it stops at B101. That's the top of the riser. And then it goes S105 to B to A102, 103, 104, top of riser, bottom of riser, backflow, and test. I love it. And look at rows 13, 14, and 15, or 14 and 13 and 14 have got the swing check and the butterfly valve, and the other one's got the backflow preventer in it. Let's run the calc. Also, the diameters are 1.25 inches for the branch lines, and the mains are all 4-inch. So we'll run the calc again. And still 15 and 24. That's good. And now
I'm getting a weird error that says something about pump calculation, misfunction, sort pipe calculate.
Weird. That is weird. Maybe I'd like to see that. Who is that?
Cody.
Cody. Let me make you the presenter. Make presenter.
See that?
Unknown error due to pump calculation, verify input, ref step, runtime error 62, input past end of file. Well, this is my chance to show that error checking stuff. So unknown error. I think I can picture that in my mind easy enough. Just pick.
It has something to do with that fuel bar. Mine did the same thing.
Okay. Well, pick OK. Specified remote node does not have a K factor. Pick OK. Calculation failed. Pick OK. And then also just double check that the other page. This is page 1 of 2 that shows 4 pipe types. Just look at page 2 of 2. That looks checked legitimately. Go back to page 1 of 2, and we've got all the lines are lines and the welded mains are mains. I like all that. And then pick, and this says return to Revit. It doesn't say cancel. So let's return to Revit. And I just want to show you the error checking the error messaging that we were talking about. And then we're going to run the calc again and check it. Escape, escape, escape. do the walker for me. And then do the walker again. I
You
think
know
I
what?
would
I bet
leave.
you money that's it.
Yeah,
Let's see.
I think we want to stop at test. We don't want. Yeah, cancel that. I want to do the walker, and I want the
Mhm.
walker to only go up to that supply point, the test point. So do the walker once. I don't think you have a system divider on the elbow that Brian and I had. You're walkering all the way to that supply point, which is that's the connected model. So do the calc now. When you were doing the walker again on the underground, you were picking up pipes that were going to nowhere.
Yeah, I didn't have that before. I thought that might be the issue. I was doing
Oh,
the up to the test point
you
before
did it
too.
this way. You did it this way before. Well, let me see
Yes,
the
sir.
error one more time. So pick continue. Okay, and this is the error I was talking about. That's not an error at all. It just says we got that
Right.
stuff, we put it here. And I would, if I were you, I'd check, don't show me that again. I don't do it on my machine so that I can show it to other people. But looks like you're okay in here, and I see your reference points the way we expected, and the equivalent lengths of the pipe and stuff. So you could calc this again, or you could just leave here. I like that. So 19 pounds, that's what Brian had, and then leave here and return to Revit. And I, I think there's nothing, like it added reference points that were already there, and it updated the
Mhm.
values in look at the answer block and see if the safety margin is 19 now. Yeah, so that updated. You with me?
Yep.
Good deal. Hover over the hydraulic calculation button and hit F1 and scroll all the way to the bottom. Now, this particular button has more ways, more things that can go wrong. It's a bigger, we're doing lots and lots of stuff, and there's along the way more things that can happen. If you're getting tired of scrolling to get to the bottom, you can use that scroll bar all the way on the right, but there is also, there, finally there. So there's so many different ways that things can go wrong. We broke them up into after clicking the continue button, during loading steps, after you're actually in the spreadsheet, when you were returning to Revit. Do you see the different parts of this big operation where we might see that error? If you want to see them all, click on the one at the very top of the list immediately after clicking. Yeah, that one. Click on that one. That'll show them all. And this is almost embarrassing. There's 44 ways to screw this operation up. But you can scroll through looking for the pictures for one that says error 1308 or one that says unknown error or whatever. You're only seeing the first 8 or 10. At the bottom is next page. And I think I've already accomplished what I wanted to here. You see what I'm after is that you could get an error and it's going to look like one of these. And if you find the one that you got, then you click on solution and it tells you what went wrong and what you do to fix it. If you're like John or David, you may have already figured it out on your own, and that's okay. Well, maybe Chris did that before. Okay. I'm kind of anxious to go on to slide 37. Brian, I'm going to make you the presenter again. Where'd you go, Brian? Make presenter. Okay, your shot. Cool. Slide 37 says, actually, Al should be the presenter. And I think I'm going to charge through the rest of the green and the pink slides, and I'm probably going to go 10 or 15 minutes over 1 o'clock. But this is kind of extra credit that we're going over here, and maybe you could even ignore it for now, and when you're trying to run a calc using a fire pump, come back and look at the recording. So if you have to leave at 1 o'clock, I won't be insulted, but I'm going to keep running the recording through calculating a pump. And if you calculate a standpipe, then there's little changes that you have to do to calculate the standpipe, and I'm going to show you how to do that. But I'll drive for the next 10 or 15 minutes and try and cover those topics. That leaves cleaning up our final printout. Still not covered today. We're going to push that off to next week also. Move it to next week. Next Tuesday. So let me make me the presenter. Al, presenter, yes. Share my screen. I'm going to share that screen. Yes. And I'm going to go on to slide 38. Recalculate with a fire pump. No, starting at slide 37. So I sent another project, which is called With Pump. And it's our 60 by 80 foot building, still with a flat as a pancake AutoCAD background, but I added a Revit little building off to the right in the corner of it to put a standpipe in. And it's a 6-story Revit building off to the right for my standpipe. So let me go to Open Revit. I think I had Revit open actually. And I've got Revit 23 open. I'm going to do open ... I'm going to go to CHES, Hydrotech for CHES, basic training. And in there, I put this project that says with fire pump. Where did it go here? So lesson 3 with fire pump. I'm opening that project. And it's very much like what we drew before. And there's that flat as a pancake AutoCAD background. There's our model, and then there's additional model for the standpipe and additional modeling for the fire pump. I'll show you that in the plan view in a minute also, but let's stick with the slides. So I opened it. I'm going to use the walker to prove that it's all connected. So over here, I'm going to just WW, pick on a pipe, and that makes me think it is not all connected. And then I'm going to WW again, and I'm going to WW again. So I had some system dividers in here already, but by walkering several times, I got the underground, I got the overhead system, and I got the standpipe system. I still have the bypass is missing and the jockey pump loop is missing. And I'll show you in a slide that's important if I'm running running a calc with the fire pump. So back to the slides. I've proved that it is all connected. I'm going to add system dividers to isolate the sprinklers from the standpipes. That's just clicking on the 2 butterfly valves and changing the property to set that system divider. I'm claiming we already showed that that was done before I started here. I'm clicking on those two, and there's that system divider property. If I uncheck that and I did the walker, then clicking on any pipe, not the bypass, but that gets the sprinkler system and the standpipe and the underground. All right, putting them back to system divider. And moving on. Then I put more system dividers on. I put a system divider at the first and last pipe of the bypass and the first and last pipe of the jockey pump loop. And that's because if I'm running a calc that includes a fire pump, I need the water to have to go through the fire pump, not sneak around bypass or try and sneak through the jockey pump. I want one and only one path available for the water, and that one path goes through the fire pump. So it was already done in this thing when I opened it, but if I click on this first pipe and this last pipe of the bypass, and this first pipe and this last pipe of the jockey pump, those things should all have system dividers on them. And now when I do the walker, the underground, the selected pipe goes through the fire pump. It does not go through the bypass and does not go through the jockey pump. So there's no sneak arounds. There's no extra paths around the fire pump. So if I wanted to run a calc on the regular sprinkler system, again, I would pick 5 operating heads on 3 lines. I'd make sure those 5 properties were filled in, and I would have operating heads. Come back here. I'm going to go to the floor plan. That's not the floor plan. I think I'll use the submittal there. And I'm going to pick a window around those heads, and I'm going to dial in just the 15 heads, and I practiced this last night and I forgot to unpractice it, so I already have that stuff filled in. I've got 0.15 over 100 square feet each, 7 pounds, and I called it A2 and that they're flowing. I've already operated my heads. I've got a water supply I'm going to put out at the street. So the supply point will be the T at the street, and the supply amount is going to be 30, 25, 1200. So I'm going out to the street. I'm going to see that on the site plan. And I'm going to make that T be the supply point. And I'll specify the water supply numbers over here. Maybe I can't put that thing on the site plan. Let me put it on the submittal. Revit encountered a parameter is read only. So define supply, hit F1, scroll to the bottom, troubleshooting. Command failure, parameter is read only. What's the problem? The cause is when trying to insert supply, this error applies. That's not very good thing, but there are 2 solutions. 1, delete the current water supply block, or 2, second solution will make it so you don't have to manually delete the info block every time. However, it will remove the water test HydroCAD extended version of the water supply. I think I'm going to navigate in the project browser to the water annotation symbols water test, and inside that group, look for the item that says HydroCAD, water test HydroCAD, select all instances in project. After it's selected, you can place down a new one. Inside that group, look for the item also called that and right click, select all instances in project, and I think we have to delete it. So I'm going to close this. In the project browser, I'm going to look for families, annotation symbols, water supply, and I'm going to select all instances in the project, and I'm going to delete them. And just to be careful, just to be sort of careful, I'm going to see if I can select all instances in the project and delete those. And then I'm going to go try putting that defined supply back in. All right. Well, worst case scenario, I don't have a supply. I'm going to have to go ahead without it. Are we messing with yeah, so we're going to do WW to select the system and the underground, and then we're going to run a calc. So WW gets the system up to the butterfly valve there, and then WW gets the underground, and I'm presuming that goes out to the street. And then I'm going to do calc, and this is complaining there's no water supply, so it's simply going to use 10 static, 10 residual at 250. And now this is what's new. If your selection set, if your Walkered pipe selection has got a pump in it, then you get this dialog box. So I'm going to put the rated pressure at 50, and I'll put the rated flow at 500. And the churn pressure for the pump, the pressure at no flow through the pump is 110% of the 50. Make an NFPA curve. That's the water curve. Dave, you remember we drew 2 points in a straight line through it when I showed you that water supply curve before?
Dave had to head out.
Oh, he had to head out. Yep. So instead of that straight curve, the fire pump gives you a different curve, and they describe it with 6 points. So we're going to go use those 6 points. And then this should all be filled out from before. I'm looking for area A2. My underground is underground. My lines are lines. My other lines are lines. And my mains are mains. And there is no page 2. So I'm going to continue. That's the error. That's not an error. You can see that I have blah, blah, blah to PO, and then PI to blah, blah, blah the rest of the way down through the calculation. I'll run a quick calc on that. And it says, so far, so good. I need 248 gallons a minute. I think I'm not picking up any hose flow, and I should have seen that when I started the calc. Yeah, there's no added flow, there's no hose flow. So I could either add that in manually or just note the fact that it's not there. And the fact that it says pressure required is minus 17 pounds, that means we have 10 pounds, which are more than enough for if we only need minus 17. When we graph this, we're gonna graph the demand at the pump outlet. or at the pump inlet, and we're going to show that the pressure available at the supply is the pressure at the supply. So we avoid showing that negative 17 pounds to the authority having jurisdiction. And he just says the suction to the pump is less than 20 pounds, which for some authorities is a red flag. And that again is because I put in 10 and 10. I couldn't get it to happen by my putting the water supply on the plan, but I can go in and tell it here. I'm going to edit the water supply. Where did it go? Edit the water supply. There. That was going to be 30, 25, and 25. I'm going to make the residual flow be 1200. And then that more accurately reflects the intended calculation. And now we're 46 pounds under the curve. Okay, so everything's good. So I'm going to close this. And return to Revit and park that answer block. And that said, there are 4 reference points someplace else. So I didn't see the reference points that belonged on here. I can pick all reference points on this view to add 1, 2, 3, 4. That looks like a whole bunch that were there before, but that'll be fine. And I want to go look at my slides again. When you insert a fire pump, and I'll maybe cover that on Friday on our final 5th lesson, fire pump. And then when that pump is part of the selected connected model, we get that question about what's the rated pressure, what's the rated flow, and it draws that curve. How does it know what a fire pump is? Well, I told you before there's 4 major things: sprinklers, pipes, fittings, and pipe accessories. Mechanical equipment is the 5th thing that can be in a sprinkler system, and the fire pump is mechanical equipment. But a air handling unit is mechanical equipment. A sump pump is mechanical equipment. Toilet may be mechanical equipment. So how does it know which one is a fire pump? Well, if you use the Hydrotech tools to put it in, it'll know that it's a fire pump. If the name of that family has the word pump in it, it'll know that it's a fire pump. And then lastly, if you click on a piece of mechanical equipment and you find additional calc info and you write capital P, capital U, capital M, capital P in there, then it'll know it's a fire pump. So that's something you probably don't need to know because you're going to use the Hydrotech tools to put in a pump and it'll just know. But that's more detail about how it knows. Similarly, how does it know that it's a hose? If you use the add device tool and you put in a fire hose, it's going to have the word hose in it, and it came from Hydrotech. It's going to know it's a hose. Similarly to the pump, if you go to that device and you find additional calc info and you write in HOSE, then it'll know it's a hose, and you'll be able to use it as an operating fire hose. Okay, quick standpipe calc. I already separated it, so I can do a walker on the standpipe and a walker on the underground. The hose valves themselves are in each one of, they're in the stairwell and they're on each floor. Each floor also has a floor control assembly, just to be representative of what often goes on in a standpipe. But the sort of the one trick here is our operating heads aren't going to be actual sprinklers, they're going to be hose valves. And for each of those hose valves, if I set the 5 properties becomes 4 properties, flowing, remote area, pressure, and flow. So I will go find those guys. Here and here. I need 500, I need 200 gallons a minute out, 250 out of the most remote one. I need a second 250 out of the other one on that furthest standpipe, and then 250 out of each additional standpipe. We only have one, so I'm going to operate that guy and that guy. So I've selected those two, and they have the word hose in them, and they came from Hydrotech so that they know that they're hose valves. And now down here under fire protection, I need to say that they're flowing. They're part of remote area standpipe 1. And the flow, I'm going to make 250 out of each one of them. And the pressure, I'm going to make this 125, 100 PSI. Okay, and then I'll just apply that. And now I have operating heads, I still have a water supply, and I still have a connected model. So I should be able to, having filled those properties in, do the walker. I have the water supply from before. I may still get yelled at about we didn't find the water supply definition, but I can get around that. And then we're going to walker the underground, we're going to walker the standpipe, and we're going to run a calc. So over here, let's do it from this view. I'm going to walker this pipe that goes over and up to the standpipe, and then I'm going to walker the underground, and that gets the rest of the way back to the supply point. And then we're going to do calcs, and I'm going to live without the water supply, same way I did before. And I'm going to say I've got a rated pressure of before. I'm going to use the same pump as before. I'm going to say 50 pounds at 500 gallons a minute. Make water supply curve, pick OK. There's only 2 pipe types here, but those are underground pipes, those are main pipes. I'm good to go. And it's a pretty straightforward calculation. There's 250 in that first couple of pieces of pipe, then 500 the rest of the way. And this is that second head, that second hose valve all by itself. And I'm going to run the calc, and even before that, I know that the water supply that it gave me, edit supply, was short. I'll go ahead and make that 30 and 25. And the flow was 1200. Okay, and then I'll run the calc again. No heads flowing, and 64 feet of elevation. Those two make sense. And it says I need 500 gallons a minute at 93 psi. I'm 64 pounds over the curve. Probably shouldn't be a big surprise. I only had a 50-pound pump, and I need a 100 psi for the hose. So at a minimum, I need to add 65 or 70 pounds to the pump curve. So I'm going to say, okay, I'm going to go change my water supply, the pump, edit the pump, and 50 at 500, I'm going to make 120. That's 70 pounds more. And okay that, run the calc. And now we've got a 5-pound safety margin. On a standpipe calc, there's a little bit more. I should make the flow be 0 and see that I don't go over 175 any place. In this case, I don't think we're at any great risk of that, but it's part of the calculation that you need or want to do. I'm going to close this. I'm going to return to Revit, and I'm going to park that answer block. And there are 9 reference points that were placed, and there's still 2 more that need to be placed. And if I went to a section view, I don't see either one of these 2 sections currently showing that standpipe. I think it will now. Yeah, here's my standpipe over here with the floor control assemblies and the standpipe. I guess I'd like one that was looking 90 degrees to this to make it this one. And maybe, yeah, that one I need to turn around also so that it's seeing that. There. Now in this view, I can add reference points. And there's 2 to 1. Again, we could renumber reference points. 1 is the actual end of the hose valve, and 2 is the connection to the standpipe. And then I think 3 is on the standpipe, and 4 is that other valve. So we're good to go. And we I'll apologize for going over here like I did, but we did cover the hydraulics stuff. The recording will be good reference material because you didn't get to actually do it, but it might be a little while before you actually need the fire pump or the standpipe. So come back here and refer to the recording. So we did have those other lesson 2 things to get caught up on, but I'm going to skip through those again today and just push them on to next Tuesday. And say, except for the 2D details and the general notes and the sprinkler legend, and then actually printing it out, we're here. That's where we are, and we've run through the calcs. Questions on today's lesson? Brian, are you feeling a little bit better at the end of today, or did I race off at the end and scare the bejesus out of you?
No, I'm feeling okay. I mean, the pump and standpipe thing is going to take some work, but I mean,
right.
Hell, it took work to learn it the first time in just regular CAD. So,
right. And learning all the other stuff is the right build up to doing pumps and standpipes. That's probably not the right place to start. So we did race through it. You do have it as reference. And I'm glad to hear you're feeling a little bit better this afternoon than you were early this morning.
Yeah, I am.
You can do this. How about you, John? Are you feeling pretty good?
That's some high quality H2O.
Right. Excellent. Well, if there aren't any other questions, I will stop the recording, and I will wish you all a wonderful weekend. I'm going to send out a homework assignment, which pretty much says, let's have you do what we've already done so far in class. If you're short on time, but you've been following along, it's a perfectly legitimate homework assignment or homework submission if you take what we did in class today or what you've accumulated through the classes so far and submit that as homework, because the homework assignment essentially do what we did in class. If you want to do your own personal extra credit, starting from scratch and redoing this stuff, we'll just make it dig in that much deeper and submit that as a homework assignment. So I'll leave you with the weekend to do that, and then another couple days to get caught up if you need to. I'll let you go. Thanks everyone for being here.
Thanks, Alan.
Thanks, Al.